นะ Hello. Hello, Atish. Can you hear me?
You are now.
I want to ask Atish if he got my presentation.
Is that the one you just linked from the chat? Do you want me to upload it here for you?
Okay.
That one, yeah? Is that the one?
Yeah.
Yeah, that was already uploaded. So I'll switch back to the default for now, yeah. But it is present. So when you're a presenter, you can just switch to it.
Okay, no problem.
But I see Dave is here. I guess I don't have to worry about you guys. I'm just bouncing around each microconference, making sure everyone has everything they need. But David could definitely help you guys out.
Yeah, I'm also bouncing around, but yes, you know how to find me. This is how I was summoned here in the first place.
Okay. Well, I'm going to be at the real-time microconference, so enjoy.
Thanks.
David, this is Kumar. Do you have this? You have the right deck for the 7:05 a.m. platform spec session, right?
Hi,
Hey, Atish.
Sorry, go ahead.
I'll defer to addition.
Yeah, I uploaded all the slides, so let me see. Is the right slide, Kumar, right?
Yes, this is the one. Correct. Yep.
Everything else I just downloaded from Indico and uploaded here, so it should be okay. Kumar, do you see the spec incorrect aspect?
It's kind of very. It's difficult to read. The font is really small.
How about now? Maybe we may have to share the screen. I think the aspect ratio is not good for a PDF spec here.
You can drag the video window left and right to make it bigger or smaller.
Yeah, you can resize the video. I mean, video and the other.
Yeah.
Now, Palmer,
like, the spec looks great on my page.
Yeah, now it looks perfect, Atish.
Okay, I resized it.
Looks perfect.
Yeah, I resized it now. So
yeah, if you zoom in too much, it goes out of the window actually. So.
yeah, no, I was not zooming in. I was trying to scrolling, but I realized they're taking it as a slide format, so I have to do the left. Okay, this should be okay.
Yeah, this is fine, Atish.
Yeah, only issue is I can scroll. So let me see if I can present my screen. That would be easier.
Yeah, looks good.
How does it look now? I'm sharing my screen. Is it better?
Yeah, now the screen is showing the the window of the documents that are there for the event.
Oh, okay, hold on. I need to share the other window. Yeah, how about now?
Yeah, looks good.
It's good, right?
Yeah, looks good.
Yeah, this one we can scroll, so we can go through it quickly rather than clicking individual. So I'll just share the screen when you want to discuss the spec.
Sounds good.
Aman, you have moderator access, right?
I think so. What?
Okay.
I'm never entirely sure what I'm supposed to be doing.
As long as you can, I think
So
you have. So
I'm supposed to present the slides in like a minute. Do you want me to take this over?
yeah, you can take it as a presenter.
Okay. I just click the button. Oh, okay. Whoa, fancy. That's it. Great. All right. Okay, I don't know where those timer slides went. Okay, well it's 7. So let's start. All right, turn my webcam on. There we go. Okay, it's 7. So we're starting. Everyone, welcome to the Risc-V micro conference. This is Plumbers. Yeah, the chat's working. Yeah, I loaded a little slow for me, but once it loads, it seems to go. So that's good. Okay, so we'll run through the sponsors and thank everybody for sponsoring Plumbers, because without sponsors, we wouldn't have conferences, I think. Diamond sponsor is Facebook. The platinum sponsor, IBM. Gold sponsors, ARM and Microsoft. Silver sponsors, AWS, Netflix, and Red Hat. Speaker gift sponsor is Collabora. T-shirt sponsor is VMware. I didn't know we were getting t-shirts. Cool. And then LF runs the conference. So that is the extent of my introduction slides. If you haven't been to Plumbers before, this is meant to be a very collaborative conference. So you're not ready to present a bunch of slides. We're here to have a discussion about kernel development and whatnot. The rules are basically to turn your video off unless you are trying to talk, because if too many people have their video on, it can start to chug. Keep your mic muted, obviously. It's a little tough to do these collaborative discussions remotely, but the system we have here is pretty good. There's a chat down at the bottom left. I'll have that open. I'm moderating the discussion, and we'll have various leads for each of the topics who have a few slides to help drive the discussion. So that's the extent of it. We'll wait a couple minutes, and then we'll get the ball rolling.
Amar, you were saying about the timer slide, the end of the talk slides. Yeah, I have them.
Did I not upload them?
I uploaded them in the morning.
What are they called?
Just a note.
Hey, sorry, David. What's up?
Sorry, just a note on the t-shirts. Yes, we haven't. Not everybody has a t-shirt this year. We're not able to physically hand them out, and shipping is a pain. But we're using them as motivation to fill in the survey, which is being sent out today after Mad Dog's keynote on the last 30 years. We're doing predictions for the next 30 years, and we're going to present what you all come up with on Friday as in the closing session. And so the first submissions for that survey will be able to have a T-shirt shipped to them.
Cool, thank you.
And the other thing to comment is please use the shared notes to take notes. Typically, we've had readouts from the micro conferences on the last day. Again, we're not going to do that this year, but it's very useful to archive the notes of what we achieved during the micro conference.
Yeah. Anybody in the room, if you can help taking the shared notes, that would be great. Other than that, if you have any questions, either you can ask in the chat room, I'm monitoring that, or anybody if see any questions, just let us know. Or you can turn on your video, raise your hand so that we know you have a question, and speaker can stop and then ask your question, answer your question.
Okay, so T-shirt 705.
Okay. Kumar, I'm making you presenter.
Yeah, go ahead, Adish.
I'll switch the slides. Oh, first I have to present. Oh, hold on. Oh, I have to be presenter first to change the slides. Okay, I switch the slides and
Sure. Okay, let's get
I'll make you
started.
presenter as well.
Okay.
You can, I think you can start.
Okay, let's get started, everybody. Good morning, good afternoon, good evening, depending on where you're joining from. So this is the Risc-V platform specification session at the Linux Plumbers conference, 7:05 a.m. to 7:45 a.m. Pacific time on September 21st. My name is Kumar Shankaran, and I head up platforms and solutions for Ventana Micro, and also head up the chair role at the platforms subcommittee, horizontal subcommittee within Risc-V International. Atish, you want to introduce yourself?
Hi, I work as a Western Digital System Software Research. I mostly work on Linux kernel, OpenSPI, and U-Boot for Risc-V, and I have been the vice chair for Risc-V platform group for last couple of years.
Mayuresh, do you want to introduce yourself?
Yeah, sure. So hey everyone, I also work for Ventana Micro and a part of the software team at Ventana Micro. Thanks.
Okay. So between the three of us, we'll be covering the platform spec, and at any point in time, stop us. We can open it up for discussions. We have just a few slides, so we'll cover the content, and at any point in time, we can have open discussions as well. So let me go to the next slide here. So in terms of agenda, we'll cover three things today in this session. The first is the platform policy. We'll talk about that next, what that means and what it means for the platform spec itself. The second is the platform specification itself. That's a separate document which governs the platforms that we are defining going forward. And then, depending on the time permitting, we can have an open discussion for other topics that we don't cover during these 2 sessions. So that's in a nutshell the agenda. Moving on to the next slide. So starting with the platform policy. So what is the platform policy? So it's a governing document that governs the policies and procedures that are used for all Risc-V platforms. It's a frozen document, and it's available at the link over there, the Google Doc link, and it's a Risc-V frozen document. In terms of the scope and goals of what the platform policy itself covers, so it specifies a common reusable hardware and software environment for portability. And what we mean there is the same software will be able to run on compatible hardware platforms without any modifications. And it also defines the structure, the definitions, the life cycle, naming conventions, branding, and everything else that are used for the various platforms that are defined in the platform spec. So in other words, if you see a term that is used in the platform spec, or if you see a particular naming convention, all of those things will be defined in the policy. So the policy is sort of a governing document that defines the specification. And this policy itself was developed and released by the Risc-V Platform Horizontal Subcommittee, which is the link for that. The mailing list is shown at the bottom there. The lists for risc-v.org, Tech Unix Platform Spec, that's the mailing list for the platform specification itself. And the group itself operates under the auspices of the Risc-V Software Horizontal Committee within RVI, which is Risc-V International. And so in terms of a goal, our goal is to ensure software and hardware are interoperable. And so we achieve that using a platform specification document. And this also promotes the independent development of hardware and software. So although we are promoting interop between hardware and software, the goal would be to promote independent development of hardware and software, such that they can be individually innovated and things can move on independent tracks. Any questions so far regarding the policy?
Yeah, so I have a question. So you said it's frozen. What is frozen? Because I can't find like a tag or anything that says it's frozen in the platform specs repo.
Okay, the policies is hosted in a different repo. So that's the link that is shown there is the document for the policy. And the platform spec, if you open the spec, there will be a link to this as well in the platform spec.
So, Pamar, what Kumar meant to say is the policy is frozen. We are not going to make any changes to the policy, or you can call it stable. But the spec itself may likely to change a little bit, not like a huge amount.
So the spec is not frozen.
No, correct. That's correct.
Yeah, that's very different than the policies being frozen, because the spec being frozen is kind of a big deal.
Yes, exactly. Yeah. You're right.
Yeah. We can call the spec stable, but not frozen yet.
Correct.
Yeah, but stable kind of doesn't mean anything, right? So frozen is the important one. We've got screwed over by stable already. Enough.
Yeah. You're right, Thomas. So the policy is frozen, not the spec, correct? Just to be clear, yeah. Okay, let's move on. The next slide, so platform policy again, touching on what it does. So it defines the structure of the platform specification itself. So each of the platforms will have what's called a mandatory base feature set, which is compulsory for every platform to have. And then it also can have optional extensions covering the requirements of entire market segments like all industries. For example, mobile or automotive or server, those will be called extensions within the specification. In terms of release cycle and versioning, so the platform spec itself is targeted to have major releases every 2 years. We're starting with 2022 as the first year, and then the next major version will be 2024. So even years will be the major releases, and we move on in that cadence. And then the amendments and extensions can be released in the audios, which is 2023, 2025, and such. In terms of naming and versioning representations, so the platform name itself is prefixed by this Risc-V word, and it's postfixed by the year and a dot separated revision. So like the example you see bottom, like Risc-V OSA platform 2022. And for machine identifier purposes, we also have a URI encoded name in the format that's shown below, Risc-V platform, Risc-V over platform OSA 2022.3. And the life cycle itself, I won't cover it here. It's there in the document. You can feel free to read it because there's a lot of material and we don't have the time to cover it today. And then we are also working on a platform compatibility test as part of the platform spec, which will be a test document for self-compatibility. And that's being developed. We expect to have that released by the summer of next year. So that would be like a self-compatibility spec that people can use to certify platforms.
Do you have any like draft of this or something?
Of what, Palmer? The PCT?
Yeah.
Not at this moment, no. So it's still under discussion. Yeah, so we have nothing written down at this point, no.
And is it going to be the same Linux-based thing that people have been kicking around? Because that's kind of terrifying.
Yeah, it's still being debated as to how we'll do this. One of the suggestions has been that there is a UEFI test suite. We can use that as well, and then link all these things together into some kind of a framework that runs either using Python or whatever. We haven't discussed that yet, but those are the things that have been thrown around, that there is a UEFI compliance test already, there is an ACPI compliance test already. We just need to, put all these things together in some manner and then get this going.
Yeah, but specifically, you're not making folks like boot upstream Linux as the compliance test.
No,
Okay.
we will not have that, no.
Okay.
So,
Yeah,
Mama,
but
any,
go ahead, Atish.
no, I was just saying, any thoughts like what they should do as a part of PCT rather than booting upstream Linux?
I don't. I mean, okay, so compliance testing is really hard, right? The problem with booting upstream Linux is that like we will be supporting hardware that is not necessarily compliant with the platform spec, right? Because there's a lot of Risc-V hardware that's not compliant with the platform spec, and right, that's true even if you ignore like errata and stuff, right? So trying to scare up some version of Linux that like both sticks exactly to the specifications and fully exercises the specifications is just not really where we're aiming for, right? If that kind of makes sense. Like if you're trying to test user instructions, it could make sense to run those on Linux, because then, sure, whatever, we're not really messing with that. But Linux does kind of deal with the brokenness of the supervisor side of many things, and definitely deals with the brokenness of the platform side of many things, right? So like in an ideal world, one would imagine having a set of tests similar to the other Risc-V compliance tests that exercise the platform spec. The problem is that like those are hard enough to run already if you don't have, like if you're not trying to dive into the details of the platform. Like they're hard enough to make in some sort of portable fashion. Trying to do that in a way that does expose the details of the platform is going to be like a ton of work. So I don't know what the right answer is there. I mean, yeah, if you have the time to put in, that'd be awesome. But trying to boot upstream Linux is going to be a huge mess. Or trying to make booting Linux the platform compliance test is going to be a huge mess.
So one thing that I didn't get is any platform that is not compatible is not an issue for it. Any platform that is compatible, if we can boot upstream Linux, it will not be the only thing in the PCT, but it can be one thing if it makes sense. If it doesn't, it's fine. We can just run some UEFI test suite after it boots Linux. But I think the only
problem is that there's way more to booting Linux than what the platform spec is going to define anytime soon.
Correct, but booting
so
platform,
you're roping in all these other dependencies, right? And then Linux itself is going to have all sorts of workarounds for things that do not like things that are not compliant with the hardware spec but are in real hardware, or vagaries in the hardware spec, or sorry, vagaries in the platform spec, old versions of stuff, right? And also we're not going to be aggressively testing the edge cases of the platform spec. We're building like a software stack that runs in production, right? Not a test suite, right? Those are like two very different things.
Right.
Yeah,
I think
okay.
let me interject. If I can, Atish, if you may just add one word, right?
Yeah, sure.
Thomas, you're right. I think fundamentally you're correct. But what we may do is we may have a version of Linux, whether it's coming from upstream or from multiple Linux Next trees or whatever, right? A bunch of trees that are there that have the
Well,
latest
try
versions.
Linux X is going to be even worse because not only that is that going to have all the problems of not whatever it's called, but it's also just not going to run because it's like it breaks all the time,
Yeah.
right?
No,
So
but what I'm saying,
that's a recipe for
no,
disaster.
that's fair point. So what I'm saying is because we need to test certain aspects of the overall feature set, right? So for that, we may use just a subset of all those things, not just a full kernel that comes from the Next, that was just an example. For instance, right, if we want to test the H extension, we may use that part of that, just the patch set that supports the H extension, right? Just an example. Or we need to test DT, or we need to test ACPI support for the server extension, right? So we may just use that part or that tree which has ACPI support there.
Yeah,
today.
but like that is exactly how all the other ACPI platforms ended up being such a mess, right? Because the definition of what worked was whatever the implementations happened to need, right?
I
And
see.
then that goes way off the rails, right? Like that's like the worst thing a specification can have happen to it is to be taken over by the implementations, because then it's not really a spec anymore.
So to jump onto that, that's why we call it a platform compatibility test. But the expectation simply is at that point that we won't achieve full compatibility testing, and there's still an additional burden on the implementers to have their own tests. And what Kumar is referring to is basically the smoke testing, where we don't have our own compatibility testing yet to have a smoke test that doesn't cover all of the corner cases yet, and then to build up on that, because a full platform compatibility test suite simply can't be created in 6 months or even a year.
Sure, I mean, I'm not saying that this is easy. That's kind of how I led with the thing, right? But my point is that, like, if you couple your compatibility to upstream Linux, you're going to end up with the hardware being compatible.
Yes, and that's not going to happen because the job for upstream Linux is to enable everything or as much that is out in the real world. And I mean, we'll be talking later about the D1, and that wouldn't be specification compliant, but Linux is eventually going to support it in one way or another. And a platform compatibility suite needs to detect exactly this kind of deviations from the spec.
Yeah, I mean, that's what I'm worried about. And also stuff like, yeah, I mean, like memory regions and stuff. We're not going to go aggressively probe for memory, you know, orderings and whatnot, right? That are going to be mandated by this kind of stuff, right? Like this is the kind of stuff where, like, a lot of things in Linux are like conservatively implemented unless there's some reason to do something complicated, right? Some performance reason or whatever to do something complicated.
Yeah, so we did have a lot of discussion around it. So maybe in future meetings, we will continue to discuss this. But to my understanding, if we do the upstream Linux boot testing, it should be at, like, let's say, just to ensure that it has right interrupt controllers, it has device tree that is being passed, or it has, let's say, H extension, all those things. Not like memory ordering or those details. It would be more of a broader smoke test rather than checking each and every aspect of the platform spec, which is not feasible at all.
And I'd argue, like, all you're really doing here is just introducing a critical loop into this system, right? Where, like, folks have to go effectively announce their hardware and get all these ancillary drivers upstream in order to, right? Because, you know, you're always going to have clocks and all this sort of stuff that needs to get up for any real SoC, right? Like, how do we start taking those things when this is not currently not compliant because it doesn't boot, right? But would be if we merge the code, right? We end up in this kind of chicken and egg thing where we're always the ones standing there saying whether or not something's compatible.
I think point taken, right? I think
that's valid. Yep. Agreed.
Yeah, so I think this is something we need to keep in mind. But point taken, Palmer, I think if you're right, if the upstream Linux itself is like a moving target and things are, it's not stable, right? Then that will be as you mentioned, like a chicken and egg problem.
I mean, like
Problem,
Linux changes quite regularly. there are usually commits.
Yeah, move on and the point taken. We'll, I think, as we discuss this more, we'll bring in all the discussion points as well. Shall we move on?
Yeah, sure.
Okay. So moving on, the next thing, again, continuing on the platform policy. So in terms of conventions, so what are the conventions used within the platform spec? So features may contain the following structural elements. What we call requirements are mandatory, which must be implemented. And you'll see this word called deprecated, which means they must be implemented in the current version of the spec of the product, and they are expected to be removed in the next future version of the spec. So in other words, things that are existing for certain features like backward compatibility or being compatible with existing platforms, but we don't expect them to be used in the future, those will be marked with this deprecated keyword in the platform spec.
So I have a quick question about that. Just looking at the current platform spec, it looks like there are already some deprecated items in there, but the platform spec hasn't been released yet. Could you talk a little bit more about what those are supposed to mean, basically?
Yeah, sure. So you're right. So in the current platform spec, there are deprecated features, and those are what we consider to be used by the existing platforms out there. So some of the platforms that are there today would use some of those features. Like one of them, if I recall correct, is the UART implementation of the 8250 versus 16550. So just to take an example, we think that going forward, that would be removed in favor of the 16550. So when we deprecate a feature, we would say what is the right feature to be used going forward, right? So there'll be a mandatory and there'll be a deprecated one. So the deprecated one is the one that can be currently used, and then going forward, we expect that to be removed, and then the mandatory one kicks in.
Okay, yeah, just as a suggestion, I would say since the platform spec hasn't been officially released by RVI, to me, it just makes sense to remove all that deprecated stuff at the moment until actually there's an approved version out there.
Paul, the thing is, the idea is, go ahead.
If Kumar, just one sentence that may clarify the situation, because the word deprecated or the term came along because what we're really doing is we're guaranteeing that mandatory is going to be around at least 2 years from now, so in the next platform spec. And deprecated is simply removing that guarantee. It doesn't necessarily say that this requirement will be removed. It also doesn't say that you're not allowed to have that feature anymore. It is only a marker that on this specific requirement, we do not guarantee that it's going to be there 2 years from now.
Yeah, okay, well, I mean, I would say until we actually release and ratify a version of this, I would suggest that we just remove all of the deprecated sections from the document, since until it gets ratified and released, there's not too much point in stating compatibility with it anyway. So it'll just help cut down a little bit on some of the noise in the current document.
But then if we do that, Paul, and the point taken, but if we do that, Paul, then immediately some of the things will be gone, meaning that like the example of 8250 that I took, right? It's gone. It won't be there at all. And then we'll be mandating things that would make all platforms non-compatible immediately.
Are there any platforms that are compatible?
Yeah, I don't think there are any platforms that are currently compatible.
I see.
Yeah,
a lot of the existing platform will be largely compatible, or compatible with the base platform.
Yeah.
And that was the intention, to keep these deprecated items actually, so that we have one version of the platform which covers the existing platforms, and later we are deprecating. So those existing platforms are not left orphaned actually. So. And
also any platform that's coming up in, let's say, 1 year, 2 year, they're not gonna to switch to, let's say, advanced interrupt architecture right then. So they may continue to have Plick. So that's why Plick is also a deprecated option, but it will be there for at least platform that exists now and platform that coming up in a year or 2 or 3.
But okay, I mean, just looking at what's deprecated, right? Like one of them is Aclint with MO software, right? So like that one would make. Sorry.
That's not deprecated. Yeah. Plick is deprecated.
So Plick plus Aclint option is deprecated, and UART 8250 is deprecated. Those two are only things that are deprecated. Marked as a deprecated.
Okay, I mean, maybe we can talk about this online or something, but like, I'm not convinced that there's systems that have that combination. Right?
So when we say Aclint, okay, let's discuss that when we are in that section, so that we can cover the broader topics. Is that okay?
Yeah, that's fine. Or we can just talk about it on the mailing list. It's really, maybe it's not worth dealing with this here because it's pretty long tail stuff.
Sure.
Okay, or we can just spend a couple of minutes, during, we are going to cover that platform spec anyway. So, I mean, we can.
Yeah, okay, we'll worry about it. We'll worry about it if it comes up. Let's try to get the ball rolling.
Okay, so quick, let me move forward here quickly. So, claiming compatibility, right? What does that mean? So, a platform product basically is compatible if it satisfies all the requirements for a base platform, and if it supports an extension, then it supports all the requirements for the specified extension as in the spec. And so no platform shall claim compatibility with an extension if it's not compatible with the respective base. And a software, from the software side, a software product claiming compatibility with the platform must again satisfy all the requirements of the platform and the extensions. And so overall, the software that works on the base platform will also work in the presence of extensions. And lastly, a software that requires an extension may not be compatible in the absence of that extension. And to illustrate this point, I have a picture. I know some of you might have questions, so let me just go to the next slide here, which has a clear picture, this one here. So overall, this is how things look. So we have a base platform in the middle, which is, as the name suggests, the base requirements. And then we have extensions that add on to what's specified in the base. And from the hardware view, a hardware platform that is compatible with an extension must be compatible with the corresponding base, as mentioned with the blue box below. But while on the right side, on the left side, the software viewpoint is that software that runs on a base platform will continue to run without any modifications on a platform that supports extensions. While on the other hand, a software that needs extension support might or might not work on a platform that only has the base framework supported. I'll pause here. Any questions on this one?
My question's not so much on this, but it's close, I guess. Like, is the platform spec compatibility required for all Risc-V implementations, or is it optional?
No, it is. It is required for all Risc-V platform implementations, yes. If you want to claim compatibility.
But is it required for all Risc-V implementations? Because there's very different between saying it's required for Risc-V platform, right, and for Risc-V.
Palma, it's more of a branding thing. So if any platform want to claim OSA compliance, then they have to go through this compatibility. If they don't want the labeling or branding or anything with the platform side, then they can avoid all these things.
Okay, so you can still have Risc-V stuff that's not platform.
So first of all, there's going to be more platforms than just OSA. So the model that we have is you have multiple platforms. You have OSA for the rich operating systems. You have N for deeply embedded, and there can be other things in between.
Yeah, that's part of the reason why I'm asking, because the M stuff has almost no requirements, right? You know,
Exactly.
so unless you're doing something wacky, right, by violating, basically the M stuff is just like you're not violating any of the other specs, right? So my assumption would be that everything has to be compatible with one of them, and that's why this extraordinarily small one is there. If that's not the case, it's going to be very hard to kind of corral everything into this spec, because we're going to have all this other stuff floating around.
So we expect other ones in the future, but for the time being, we're going for the big ones: desktop server, OSA, and M for anything deeply embedded, IoT, whatever. And within each of these lines, in each of these platforms, we have the concept of the base platform and the extensions. That's where you have the is-a relationship that we just talked about. But there might be additional ones next to it, and nobody forces you to have compatibility with a platform if you're Risc-V compatible. So if you just do your chip that is for your own special market, branded as Risc-V compatible with the profile, with the ISA, and forget about the platform, because it's just for your special market. While the platforms are when you have software or binary compatibility requirements.
I guess my worry there is that every hardware vendor thinks they're special until they try to actually run software, right? So like if there's nothing to kind of keep this all together, how are we going to get folks to actually use it?
So that's where the branding thing comes, right? So if the platform wants to be claimed, let's say, I don't know what the exact branding would look like. That depends on the marketing and all. We'll know more by Summit. But let's say, for example, they want to claim that we are OSA platform compatible. That means it's guaranteed that we'll boot Linux. We not yet decided upstream or whatever. We'll decide them, but at least they have patches for so that they can boot Linux or other operating systems. So that means they are OSA platform compatible. So it's an incentive for them rather than I don't know, it's a forced handcuff that you have to be compatible. If they don't want to claim, I think that should be okay.
That's correct. So people are free to build their own platforms. Pamar, the key thing as we are mandating is that if you want compatibility, then you have to follow the spec.
But no, it's if you want compatibility with the platform spec, you have to follow the platform spec, not correct. If you want compatibility with Risc-V. So that I'm super worried about, because like that is going to lead to a lot of things that are incompatible.
Which one, Pamar? You mean the compatibility to Risc-V versus platform? Is that what you're saying?
Yeah, if the platform stuff is optional, my worry is that people are not going to follow it. Because like I said, everyone thinks they're special, right? So yeah.
Palmer, so this thing actually grows organically, right? We can't cover at this point. We don't know what all segments Risc-V will grow eventually. So we have to do this organically and include the domains as and when more and more platforms come up, right? So.
And we can't really force any vendor comes up with a platform in I don't know where and what specifications they implement. So unless they want to be known as a platform compatible, they have to follow the spec. But there won't be any, either they have to be compatible with something, right? They have to be compatible with a profile. They cannot simply say that we are Risc-V compatible and claim that we can boot upstream Linux. That's not going to happen.
Why not? I mean, there are many current systems that do that. So I'm getting some crazy on the audio. Is that my end? Sorry, guys.
So wait.
Philip, you are breaking up bad. Philip?
Yes.
Okay. Sorry, Philip, I just muted you. Blowing up.
Yes. Go ahead, Pamar.
Okay, I couldn't hear you. Sorry.
No,
I think Philip's mic was either creating a static noise or something.
Yeah. Okay. All right. I think I clicked the mute button on him. I was just apologizing for doing so, but I couldn't hear anything else, so I figured I'd just whack it. I also forgot what we were talking about.
You're talking about the bigger question where, let's say, what prevents a platform to be just claim that they are, let's say, Risc-V profile compatible? Philip, your voice is breaking.
Yeah, Philip, it's going off the rails. I don't know if you can hear us.
Philip, we cannot hear you, Philip. I think it's
let me mute him.
completely normal.
Can you mute him?
Do you know yeah, I just click on him and it mutes him. Do you guys have like his phone number or something? You can call him and tell him that something's screwed up.
Yeah, I do, but I think if I step out, then I'll.
Yeah, right. Right.
Anyway,
Anyway, so my worry here is that there are many systems now that are not compatible with the platform spec because platform spec doesn't exist yet, so people weren't following it. That's fine, right? Those systems exist and boot upstream Linux. So, like, as the platform spec becomes defined and there are systems that can be built that are compliant with it, right? How do we get folks to actually do that when there are a host of existing systems that are not that way, right? And we already support those. Right? Like this is how these things tend to kind of not get followed, right? You know, if you had to have platform spec compliance, which right now is very minimal, right? It basically just says you've got the other bits of the spec, right? In order to have Risc-V compliance, then at least we'd have a chance of getting everything kind of corralled. Maybe a release or two would go by or something. Right? But if that's not the case, we're kind of just going to drag on forever with all these other specs. All these other platforms that are not compatible with the main one.
Yeah, so I think let me take a stab at answering that question. I think good point, Baba. Firstly, right, the one thing is that once this platform spec gets frozen or released, our goal would be to have something or some example platform that follows the spec. So one of the things we are thinking is firstly have QEMU that will be a compliant platform that will follow the spec. And then in the first part of next year, we actually have hardware platforms that would again support the spec, right? So there are examples of platforms that will follow the spec. So that sort of creates a cadence of compatible platforms versus people, doing their own thing and then fragmenting the ecosystem again.
So I hope you can hear me now. I had to reboot my entire audio setup. Yeah.
Yes, we can hear me. We have 5 minutes now, guys. Okay.
Yeah. And what we have in the policies, we're actually trying to say that people should not create new platforms if this is just for fringe interest. So if you're just doing Risc-V chip to have your own hard disk controller, you shouldn't be writing a platform specification because this will be a fringe interest. But we have this in here as a mechanism when software is developed independently. There will be multiple software vendors, multiple hardware vendors. And that's why we have that intentional gap that you don't have to follow a platform. You can still have a compatible chip. And in that case, there is no statement regarding compatibility. But we expect people to, first of all, want to follow the platform spec and be platform compatible, both with software and hardware, so that they know when they get a Linux distribution off the shelf, it's going to work with the hardware that they source.
Yeah, no, I get we all want people to be compliant with the platform spec, right? Because it's going to be a mess to have all these crazy platforms out there. Like everybody else has seen that before, right? My problem is like, how do we make that happen? And if there's no enforcement of the platform spec, it's not going to happen because in practice, that's how these things
go. But practically speaking, how do you enforce?
You can't call it Risc-V unless it's compatible with the platform spec, just like the other specs.
Hold on, but
compatible with the platform spec, but the way the enforcement is going to happen is because people will be moving with their feet on the software investment side. You don't want to have your binary distribution targeting every possible combination and every possible broken platform.
Yeah, I totally agree. But in practice, folks are going to build binaries for the systems that run. And we're all talking about kernel stuff here. It's not user space stuff, right? And the kernel is very good at handling weird platforms.
If there is a market, people will do that. It all boils down to investment and return on investment. And we can write as many platform specifications as we want, but the only thing that we can do with that is create the branding and the badging that communicates things to people and that has some testing behind it. There will be things happening next to it, and people can build whatever they want if they aren't looking for the Risc-V compatible with a platform logo.
Okay, so let me interject here, guys. We have 2 minutes before the end of the session, and so if it's okay, I mean, these are good discussions, but maybe we can move on here because we just wanted to cover one more thing here. So let me just go on. We have like 1 more minute now. So for 2022, we are defining these 2 platforms, as you see here. OS-A platform, which is like a rich OS platform for Linux, FreeBSD, Windows, and all that stuff. And then within that, there is a base and a server extension. And we are defining an M platform, which is an RTOS platform, again with a base and a PNP extension. And the schedule was we are shooting for a frozen version by Summit in December. So that's the goal. And the link to the spec is up there. And so Atish, can you share the spec just for like a minute? We'll quickly walk through it and we're done.
Yeah. I don't think we have enough time, but we'll see.
Yeah, just a minute. I'll just quickly go through the sections within the spec in a minute. And while he's bringing that up, what I wanted to say is, this spec is open to everyone. Everyone can take a look at it. And yeah, so let's just cover the table of contents here because that's all the time we have today. And so as we spoke, the document itself, again, is divided into 2 sections. The first is for the OS-A platform, and then we talk about base. So base like 2.1. And then we go to the server extension, which is, if you scroll down a little bit, Atish, the server is at the bottom. And the server extension 2.2. And similarly, there's an M platform. If you further keep scrolling down, there's an M platform definition. There you go, section 3. And then similarly, within the M platform, there are 2 sections for base and extension, the PNP extension. It's been reviewed by some people. It needs a lot more review. It's open, so there is a link there. As I said, you do take a look at it, send us feedback over the mailing list, and we'll gladly take all your comments and respond. And it's an interactive community here, so feel free to suggest whatever you think is the right way to move forward. Right, and then that's all. So I mean, you can see the sections here. So we have gone through a lot of detail in putting the respective features in each of the sections. For instance, PCIe, you see here, there's security, RAS, these are part of the server extension. And then above, if you scroll up a little bit, back to the table of contents, Satish, like page 2. Yeah. So page 2, we talk about general ISA profile requirements for the base, then the PMU stuff, PMU counter requirements, debug support, interrupts and timer. So there'll be an interrupt session happening next by Anup. And then we also talk about system peripherals, boot process, OpenSDI, UEFI, everything that is covered here. And that's the structure of the document. I think I'm pretty much out of time here, but any other questions or comments, we can take it over the mailing list. And any last words, Atish, from your side?
No, I'm just saying you can ask the questions in the chat also. It seems to be working. So we'll be monitoring that and we can try to answer some of them.
Okay, that's all, folks, for this session. Thank you all for attending.
I think in the interest of time, we'll switch to the next presenter. Anupa, I'm making you presenter.
Okay.
Do you want to share your slides or should I just show the slides here?
Yeah, you can just show. I mean, I can.
Yeah, just click. Yeah, you can just click the left plus button and then you should be able to switch the slides.
Okay. Yeah. Can you see the slides, right?
Yeah, we can see the slides.
Okay. Okay, so I guess I'm running 2 minutes short anyways. Okay, hello everyone, I'm Anup. I work for Western Digital System Software Research Group along with Atish. and I've been doing a lot of open source contributions like Kernel, OpenSBI, then U-Boot and other stuff. And on the Risc-V international side, I have been for a year. I've been chairing the AI group, the task group, which is responsible for coming up with the new interrupt controllers for the Risc-V platforms. So I'm here to talk about that today. So so I'll just first give a brief overview of the specs that we have been working on, and the AI group and the platforms group as well, and then we'll move towards the discussion. And in between, like, feel free to just stop me and just ask questions. And since these are really relatively new spec, I want to spend some time in overview. So like I'll spend like 10-15 minutes on the overviews. These are like relatively big specs, so maybe I might not be able to cover all the features of the specs. So we'll start with the AI spec. Okay. So first of all, why we started thinking about having a new interrupt controller is that the existing platforms mostly have, all of them have actually Risc-V Plick, okay, or originally which was Sci-Fi Plick actually, and this is widely used. Almost all Risc-V products, even embedded ones and the Linux capable ones, have this Plick actually. The problem with some of the problems that were brought to our notice, or in one way or other, are as follows: mentioned over here as limitations. So first of all, is like it takes the address space is quite sparse. It takes like a lot amount of physical address space. So just to give an example on the Sci-Fi Unleashed, actually, with just 4 hearts, it takes more than 2 MB of physical address space, and then worst case, it can go up to 16 MB. And then there is also issues like all the address registers are not grouped properly. Let's say if you have a same Plick targeting both M mode and S mode, then there is no proper protection of the global registers, which can influence the interrupts which are being routed to the M mode from the S mode. So that again becomes a problem. Then there is no configurable IRQ cell line sensing, or how to configurable way of changing the way the interrupts are sampled by each IRQ line. Right now, it's like kind of hardwired in each platform which integrates this Plick. So, of course, there is no MSI support, and there is no virtualization support as well. Yeah, and to solve these problems, of course, and give new features so that the interrupt support in Risc-V platform is like in feature parity with major architectures. This AI group was formed, and then we have this spec. So the AI stands for Advanced Interrupt Architecture. Okay, I didn't name it, so leave it the name. But the spec is in quite stable state. We have done a lot of POCs in past 8 months, and so it's and the goal is from the Risc-V Internet that it's supposed to be ratified by Summit, or at least frozen by Summit at least. So at a high level, actually, it adds 3 distinct components. One is the new CSRs, what we call it like extended local interrupts, extending the functionality of the local interrupts that is already there. And then we have the most highlighted part of the spec, which is the IM6, or the incoming message signal interrupt controller, which primarily handles the MSIs. And then we have the advanced Plick, or the advanced platform level interrupt control. So, so the A-Plick is not backward compatible to Plick, just to clarify. But we have a dual Plick mode, which is like a Plick and the new Plick can coexist if people want that level of compatibility. So that's there, but that's a separate topic, and is that defined in as a separate chapter in the spec. I'll not go through that part. And the point behind keeping the AI spec modular is that platforms can implement only the required parts of it. For instance, if we have a low-end system running Linux, which does not have PCI or any MSI, then they don't really need to implement the IMSIC. Okay, and for that matter, if they don't even have virtualization, they don't even need to go for the AI CSRs as well. They can just add just the APLIC part of it, and then they are done. So that's why it's modular actually. So just to quickly go over like the high level features, like so the extended local interrupts actually allows the platforms to provide 64 local interrupts for both RV32 and RV64 modes, and the priority is now configurable. So at this point, right now the previous spec does not define any priority clearly for each local interrupt, but this will have a configurable priority, and it also has interrupt filtering support, which means that higher level previous mode can take the interrupt first and then forward it instead of directly delegating it like the previous spec does. Okay, and the original behavior of local interrupt 0 to 12 will be defined by the previous spec, and that will not be modified by these AIS CSRs. So actually the CSRs are totally backward compatible. So in a newer system with AIS CSRs, if we run an older software, it should be totally fine. It will not break. And it also has additional CSR, especially for IMSIC for faster access, because the IMSIC is like kind of indirectly access through CSRs only. But then we have CSRs for faster access just for the IMSIC. And moving on to IMSIC as such, so IMSIC requires each heart to have its own IMSIC instance, and each IMSIC instance will have multiple interrupt files. So there'll be like one M level file, one M level interrupt file, there'll be an S level interrupt file, and there'll be multiple VS level interrupt files. And having all the files are not mandatory. For implementations which don't have exception, they can just skip the VS file. They don't need that. And for implementations that really don't want the S mode, then they can just go for M file only. So it's quite modular in that sense as well. And each file actually has two parts. One is the configuration and its own state, which is configurable through the CSRs. And then the external part of it is through the physical address space, where we have 4 KB for each file, and it will have just a couple of registers, which are the MSI registers, where the devices can write or other CPUs can write. And for IMSIC, the AIS CSRs kind of become mandatory. And it supports up to 2047 interrupt identities. And yes, it also supports MSI virtualization, which is through the VS level files. Any questions so far?
Anup, there is a question in the chat where it says, why is the address space usage is a problem? I think it refers to the
Plick
address space, yeah.
Yeah, so that problem was brought to our notice by some of the low-end embedded guys. They were complaining that why we need to have so much, reserve so much address, because they were 32-bit platform, and then they don't want to reserve so much for just for a Plick. So that's when we hit that, okay, low-end systems, really low-end system will hit this problem actually, why they are reserving so much, because even though they have this 4 GB of address space, they really want to still cut it down and they want to reduce the address comparators and what. So
yeah, PA space can be pretty expensive.
Yeah. Okay, so moving on to the APLIC. So one major change with the APLIC over PLIC is, yeah, of course, physical address space consumption will be less compared to the PLIC, of course. But then, like I said, we need to clearly isolate the register which will control the interest being routed to the M level from the S mode, and we need and we'll be able to protect those registers using PMP and all those things. In addition to that, it also adds a hierarchy of APLIC domains where all the wired interrupts coming from the devices will connect to only the root domain, and then the root domain can delegate to child APLIC domains, and then implementation can select the number of domains it wants. I think a decent number would be 2, of a root and just one S level domain. A single root is also fine. For example, in case of virtualization, we generally emulate only one APLIC domain. That's it. It just directly targets the S mode. And configuration is totally memory through memory mapped registers. And yeah, like I said, AIS CSRs are not required actually for APLIC. If a platform just wants APLIC, just wired interrupts, it does not need to implement other parts of the spec. And it has target registers which were not there in the PLIC, which allows us to directly pinpoint and target a particular IRQ to a particular heart. So, and it supports up to 1023 interrupt sources, wired interrupt sources, and up to 16384 hearts. So another unique feature of this APLIC is that it supports 2 modes. One is a direct mode and MS. So direct is like no brainer. It directly APLIC injects interrupt directly to the hearts without anything in between. But the MSI mode is a bit more interesting, where it actually converts all the wired interrupts into MSIs and forwards them as MSIs to the actually IMSICs. So which allows both APLIC and IMSICs to coexist together nicely. Yeah, so just to for benefit of everyone, I try to prepare some figures so that the figures or the high level thought is in everyone's mind when the patches land, and people can provide good suggestion in the reviews of patches. So this is what I was talking about. If we just look at the IMSIC or the IMSIC part of the things and the local CSRs, each heart has its own local CSRs, and each IMSIC is like per heart, and where each IMSIC further has multiple files which for different privilege modes. And yeah, of course, people can have implement only required number of files. And the devices will directly shoot MSI. So the dotted lines in this figure is the writes, MSI writes, and the hard lines or solid lines are nothing but hardwire connections. Okay. So this is basically what I explained about the IMSIC. Any questions on the IMSIC so far?
Sorry, I think we're all still arguing about the previous session in the chat. I can't have two discussions at once.
Okay, it's okay. Yeah, cool. Moving on. Yeah, so same thing, like I said, like if we just have wired interrupts like on any platform, we really don't need an IMSIC in that case. In that case, it will look something like this. But I've shown only 2 domains over here. It can have more domains or just a single domain as well. Okay. But then the cool thing is that we have a separate M level domain and a S level domain, which means that now we can protect the M level stuff, and the M level IIP separately using PMP and other stuff. Even I have PMP, we can configure for that, or some other protection. So the S mode will only have the access to the APLIC domains which are meant for S mode only, or S level. And yeah, so since this system does not have MSIs, all even PCI devices and all MMR will directly inject interrupts as wired interrupts only. Yeah, and this is a more full-blown case of the system having both the APLIC and the IMSIC. Like I was saying, all the wired interrupts will always connect to the root domain, and then they can delegate to either some of them to S mode or handle directly in M mode. And the typically PCI devices will directly inject MSIs to the S level, and the APLICs in this case will run in the MSI mode, and they will convert the wired interrupts as MSIs and inject to appropriate IMSIC files. So this is like the high level view, the larger view, I would say, behind the whole AI thing. It covers almost all 3 components in this figure, actually. I guess people are still busy with the previous session, or okay. So moving on. So yeah, so the immediate question is that okay, if we have totally random organization of all these files in the memory map, then the APLICs won't be able to actually inject, and the APLIC hardware will need to have a separate base addresses and for each target IMSICs, which would be more expensive for hardware as well. So what we came up with this is that we have this notion of IMSIC, recommended way of arranging IMSIC files in the physical address space. Which has this notion of an IMSIC group. IMSIC group is nothing but hearts co-located, hearts with having all the IMSIC files as co-located in the physical address space. And so the group can also be thought of as a cluster within a SoC, or it can be also thought of as a die in a multi-die system, or a chiplet, or a socket in a multi-socket system as well. So this figure actually shows how that will be organized into, let's say we have a multi-group system, then how would the files be organized? Typically the M files will be co-located to each other within a group, and then the S files will be their supervisor level files. And within S files, we'll have the VS file and S file separately co-located. Yeah, I guess this has been older, right? Like we can skip this is too much into the spec. So this is like saying the same thing, but how the APLIC expects, and even the APLIC assumes this arrangement, so that we can configure the target registers when it is in MSI mode to target appropriate IMSICs. In the interest of time, I'll just keep this thing because it will just take more time. Any questions till now for the AIA? Am I audible or am I just?
Yeah, you're audible. I think everyone's
Okay.
just.
There is
Lost
intro
little bit of-
silence.
There's too many other discussions going on, and this is quite deep stuff. Sorry, Anoop.
No
I was
problem.
this
Yeah, it's okay.
being right after the big argument session tends to get.
Yeah, once we figure out how to create a BOF, probably we'll set up a BOF for this. No, just kidding. Look, we can continue. There are no questions until now.
Okay. I thought I was speaking to myself, but anyways. Okay, so and a very short introduction about the ACLint. Yeah, so I think based on the comments I mean so far, like I think there is a confusion about the ACLint, how I approach it. So ACLint is totally backward compatible. Okay, so we need not to worry, and all the existing platforms are already compliant with the ACLint, so to say. So okay, why ACLint is that we are already familiar with Sci-Fi Clint, and we have almost all systems having Sci-Fi Clint at the point, which basically provides a M mode timer and a M mode software interrupts. Okay, but then there are problems. Okay, and we ran into some of these problems when we were defining the platform spec. First of all, the problem we ran into was like once we have a system like AIA, which has Emc and everything, we really don't need the IPI part of the Clint, Sci-Fi Clint actually, because we can always use the Emc to inject IPS to each other actually. And which becomes even more faster in case of virtualization, because we can totally inject IPS to each virtual CPUs to each other in a trapless way. So that's when we wanted to define the Clint, take the Sci-Fi Clint spec and define in a more modular way, so that we can just implement platforms can just implement the timer part of it. And then another problem was there is no provision for S mode software interrupts, which means that Linux and other OS will end up doing SBI calls most of the time. So there needs to be some provision at least, and particularly for the low-end systems in future as well, where it will have just APLIC, it will not have PLIC, but it will just have APLIC. In those systems as well, we need some provision for the S mode to inject as IPS directly. Another problem also what was like brought to our notice is that, okay, we might end up with situations where we have multi-cluster systems where the compare registers of the timer are local to the clusters, but the M time is somewhere else, physical M time register. So at least we need to define the M timer or the MO timer such that at least two different M timers can share the same physical M time register. So based on whatever the limitations I spoke and other things, we came up with this modular spec. Is basically Sci-Fi Clint plus the modularity and the new stuff. But the new stuff is only the S mode software interrupt. That's all. So we can also, so we have three devices. Okay, now targeting separate functionality. One is the M timer, another is the MSWI, another is SSWI. And then now the Sci-Fi Clint is also a Clint device. Just we can think in one Sci-Fi Clint device as two Clint devices at this relative offset range. So that's why I say that existing platforms are already compliant with the Risc-V Clint. Any questions on the Clint part?
Yeah, could you talk a little bit more about why it's important for it to be, whatever spec is defined here, why it's important for it to be backward compatible with the existing Clint?
Yeah, so backward compatibility was like one of the requirements we got in AI context as well. In other that the existing platforms need not be orphaned so fast. And the other thing is the modularity as such, the required in the Clint spec. So, and I mean, there was no as such issues. If you see the limitations, what I have highlighted, what we got so far, nothing to do with the functionality of the things as such. It's just the newer system needs more modularity and more sharing of some of the resources like M time register. So as such, we didn't require to break the functionality as such. And another thing was, if you look at the Risc-V privilege spec, particularly the machine mode part, it clearly defines expected behavior of a memory mapped M-time and M-time compare. So anyways, we can't violate that behavior from with the Risc-V privilege spec as well. So that part has to be compliant with the Risc-V privilege spec, and also it has to be compliant with the sci-fi client as well. Paul, did I answer your question or did I confuse more?
No, it's fine. I think we need to at some point, and probably the RVI group is the right place to discuss it. Is just to get a little bit more clarity on whether that's really a key requirement for this. That's all.
Yeah, mainly you can see there is a clear distinct section in the privilege spec about the M-time expectation around the platform M-time and M-time compare registers. So if we try to align with that, we are already compliant with the sci-fi client. So okay. So one last thing regarding the overview. So we talked about AIA, different things that AIA has. We talked about A-client and the 3 modular devices it implements. So where does this whole thing actually fit into the platform spec that is coming up? So out of all these things, we came up with like potentially 3 categories or classes of interrupt supports, or 4 categories at this point, which can be there in any platform at this point. Okay, first is the legacy wired IRQs, which is right now marked as deprecated, which essentially is this combination, the whole row actually. Okay, it does not mean that the whole row will be deprecated, all the devices will be deprecated. It's the combination that is deprecated. So which is essentially meaning that a system with a PLIC and MSWSI and M-timer. So both these are part of sci-fi client. So instead of having a separate sci-fi client spec, we can just point to this combination. That's all. And the next is the immediate upgrade on the existing legacy wired IRQ system is an only wired IRQ system which uses the newer components, namely the APLIC M level domains, APLIC S level domains, and more A-client modules like so. So in the legacy, we don't have anything to inject interrupts in the S mode. So over here, we are on this case, we are actually asking, since there is no IMSIC, we are asking to have a mandated SSWI device, which allows Linux to directly inject interrupts without SBI calls, okay, directly to the S mode. Okay, but this does not talk anything about VS level at this point because the A-client as such does not support virtualization. So it's just more about documenting the old stuff. So in a more modular way. And then the new thing also is that in the second row is the pre-SSTC, which adds more CSRs for direct programming timers in the S mode without doing SBI calls. So that stuff is still in progress. And in all this diagram also, the colored boxes are kind of either work in progress or already complete. So wherever I've written phase 1 and phase 2, those things are done. And where there is a in progress, that's still work in progress as far as POC goes, not the spec. And the third combination is again will be more common also is that we'll have a system with MSI and wired IRQs, which means it will have IMSICs, but it will not have a virtual MSI support, which means it's a bit kind of mid-range system which does not need that much virtualization, but it needs MSIs and wired IRQs, which means it has PCI and a few set of wired peripherals. So in this case, SBI, so in this case, we'll mostly have IPIs done through the IMSICs actually. And rest of the things are same, MSIs for IMSIC and APLIC for wired interrupts. And yeah, as you can see in the M level column, the M timer part of the A-client still gets reused. And that's where the modularity of the A-clients come into play. We don't need to have a full-blown sci-fi client. We just need the M timer part of it. And that's it. So this will also stay compliant with the privilege spec as well. So, and the last is at this point will be the kind of most advanced system which has even the virtualization support in the IMSICs, and that's why you see even a VS level IMSIC file over there. So the rest of the things are same as the previous row. Yeah. Any questions in this thing? This is related to the platform spec which we were discussing in the previous session.
Yes, so the first option was the one when we say legacy, means like that was the mark as deprecated in the platform spec.
Yeah. So it's the combination that is deprecated, not the components, right? So
yeah, exactly. For the reason we described. So any questions we can discuss now, like why it is being deprecated or anything.
I have a question about what IO interrupt line is, wine one or the MSI is one? Because I met the most performance problem for the IO is about the what notify and the PRS emulate. It costs very so much emulation pace to handle the IO interrupt currently in our virtualization implementation. So how we solve the IO device notify and interrupt handler to increase the performance, to prevent the virtual machine VM exist or enter.
So one thing is that whatever need not be always on the as an MMI bus. So let's say you have the last combination which has the Emc VS file. Okay, in that case, it can very well be a VirtIO PCI transport for the VirtIO. Okay, or the PCI transport for the VirtIO. In that case, whenever the VirtIO will inject interrupt, it will be simply a MMI write, and the VMs will typically process the MSI in a totally trapless manner. There'll be no traps at all.
Yeah, okay, I got it. I got a little bit, but how to handle the notify? I mean, for example, the standard VirtIO front end driver using the VirtIO spec, and when he want to notify the host, he just write the notify in the config register, and that will cause the MMIO emulation, and it's a long path. I just a question is how could we solve this problem in your spec? Is that possible? Or because we have measured some cost of this scenario, it's cost a very about 20% of the performance. That means if we using some hardware mechanism to let the notify directly give out to the host, and the guest didn't VM exist, then the performance will increase immediately.
Yeah, so if I understand correctly, so your problem is the reverse. So all this spike or the interrupt controller, in fact, in other articles as well, if you see, most of the interrupt controller level virtualization is all about from the host to the guest, how you can deliver the interrupts in a fast manner or without traps and accelerate those things. And what you are asking is the reverse thing, where you want the reverse notification to be faster. And that's kind of a new area, I would say. Okay. And okay, it's kind of overlapping with this, but it's not exactly interrupt control. It's very centric to virtualization, where you want a reverse notification from the guest to the host to be faster. Probably it needs fresh thought in a different way, but it has. I mean, it looks similar to what we are trying to solve here, but I think it's nothing to do with that, because like over here the problem is the host interrupt controllers and the virtualized support in the host interrupt controllers as such. Okay. Yeah. So yeah, this is the new research area, I would say. So
yeah. Okay. Is this question okay? I mean, how do you think let your spec connect to the VirtIO spec? That means a little bit misc. That means your AEC, your how to say that, your AIA, yeah, your AIA specification contains some VirtIO specification. That means to solve some VirtIO problem.
However, it is like in the recent KVM forum, there have been a lot of talks around the VDPA. Okay, so and then you can always have the VirtIO being totally accelerated by a hardware, and where the hardware will have two sides of interrupts. One interrupt on the host side, where using that interrupt, the hardware will accelerator, whatever accelerator will directly notify the host. And then the forward thing is also there. These interrupt controllers can be used to directly inject interrupts through to the guest. So again, the answer is over there also. What I saw, most of the optimizations around VDPA were to put more things in hardware, accelerate what with hardware. So, and that would actually accelerate what you are saying, the reverse path as well, the guest to host as well, because now the whatever is actually totally in hardware. So, and you can just have a simple interrupt line directly being taken by the host. There is no.
Okay. Yeah. Okay. I mean, if we want to solve this problem, maybe we also will involve some custom design.
Yeah. Like I said, it's a research topic. It will require some new hardware.
Yeah. And sometimes how to upstream it is the problem. So I think if you can take care of this, maybe it's much more easy for us.
So at least for AI, I would say at least the goal. I mean, whatever is set out for this year has been already completed. POC has been done. So if people think this can be solved through AI, maybe the AI 2.0, when people work on that, can address this. Try to address this problem if they can think. Or I mean, there is already a lot of work going on with the DPA and hardware accelerators for what I have. So that will be another topic. So.
Yeah. Okay. Another topic. Okay.
Okay.
Okay. Thank you.
Yeah.
So we're kind of out of time.
Yeah, I know that. Okay.
So I
but
think.
Anyways, I have uploaded the slides. These slides are not the latest one. I have added more figures for people who want to get started reviewing and following this stuff. Actually, I have added more detailed slides just for the benefit of everyone. Okay, so they can pull the latest slides from the Plumbers site and go through it. And if you have questions, just email us. So.
So we have 15 minutes break now. So if you have any questions, you can ask Anup or continue discussion here as well.
Okay.
But officially we are on break. So if you have anybody else has a question, you can continue discussion. So I'll just take over the presentation and switch to the break slides. Sure. And we'll be back at in 10 minutes with next session as an ACPI for Risc-V. Amar, where is that slide with all the talk details and the break? Can you share that one? Yes, Palmer is not here.
Yeah, he's probably not at his desk.
Then I got it. So we are done with 2 talks. Now we are at break. Okay.
Tish, can you hear me?
Yes.
Yes.
Okay.
Yeah.
Okay. Thank you.
This is a pretty cool slide, Atish. How did you get this thing done? You changed the highlight after every session?
Just different slides.
Oh, I see. Okay.
So Kumar, I'm trying to set up a BOF to continue the platform specification discussion.
Okay.
So, so that we can discuss all the things that were incomplete. Probably it's set up on Friday.
Sure.
Does that sound okay?
Yeah.
Yeah, Friday, same conference time around maybe 10:15 a.m. PST. Or not, or yeah, I am still confused with the time slots it shows, but it should show up in calendar. So
Is it a live session, you mean?
yeah. So BOF means it's an informal discussion session. So you can just focus on the platform related discussions with everybody concerned. Whoever has questions, we can discuss.
Yeah, I think David also shared a link out to that actually. So the chat.
Oh, 10:15 a.m. PST?
I'm still confused. Is 10:15 a.m. or 9:15 a.m.? I think 9:15. 4:15 GMT. What is this? Probably 9:15. It's at 9:15 a.m. Friday, along with other BOFs.
Sounds good. Okay. And how long is this for? I'm just checking for
45 minutes.
Okay, 9:15 to 10. Sounds good.
Yeah. You don't have any other conflicts, right?
I do, but I can move that 9 to 10 to a different time.
Okay. Thank you. I'll ping Philip as well. Not sure if he's here. So
Philip was usually in that same meeting, so that I have from 9 to 10. So
okay.
that's fine.
Thank you.
He can probably join us here.
Okay.
Atish, you said you'll send an invite into the calendar, right?
Do you want me to? I can. No, I just said it's on the Risc-V session calendar. I'll send an invite as well.
Sounds good. Okay.
Sunil, I have made you the presenter. So do you want to use the default, the slides I uploaded, or do you have any updated in the slides?
No, when did you upload, Atish?
Today morning, I downloaded from the Indigo website.
Okay, I think that should be the latest.
Okay, so you just click on the left, bottom left, the plus button, and switch the slides.
Okay. Okay, I think we can start, right?
Yes, you can start.
Okay. Hi, everyone. Thanks for joining the session today. I'm Sunil, working for...
Sunil, just to interrupt, just wanted to say one thing is, can you just give the context why you have the, because we didn't cover this in the platform. So you have the slide saying it's ACPI is mandatory for server extension, right?
Yeah, I mean...
Okay. Yeah, then continue, sorry.
Okay.
Continue.
Okay, so this session we are going to discuss how we can enable ACPI for Risc-V, which is a key requirement for enabling server class platforms. As Atish mentioned, we have made it mandatory in the platform specification for server extension. So here's the agenda for the presentation part of the talk today. I mean, I plan to quickly finish up this presentation in 10 to 15 minutes, and rest of 15 minutes is available for discussion. First, we will briefly talk about why ACPI for Risc-V server class platforms. These questions are already answered for other architectures, so I don't want to go in detail about this, but still as a first starting point, we will discuss about this. And there are some hardware requirements we have put for ACPI enabled platforms. We will discuss about that. And then what it takes to enable at least basic ACPI support for Risc-V. We have done some investigation, and based on that, we will discuss what it takes. And based on that, we have done some proof of concept work, and we'll share what changes we have done to boot ACPI enabled kernel, Risc-V kernel on QEMU. And this is mostly a basic enablement of ACPI. What are the pending things or advanced features of ACPI which we need to enable in future? We will discuss about those next steps. And I have put it as Q&A at the end, but this is more of a discussion. So please feel free to interrupt me at any point of time with your feedback or any questions. So why ACPI for Risc-V server class platforms? So basically, ACPI is the preferred choice of enterprise hardware OEMs or OS vendors because of various good reasons. And in a way, for some vendors, it is actually a mandatory requirement. And these requirements and reasons are already documented for ARM64 server, documented well by Grant, and Risc-V is not a exception for these reasons. So this learning from ARM experience we have adopted in our platform specification and made ACPI as the mandatory hardware discovery mechanism for server class platforms. And the plan regarding the hardware requirement, the plan is to support ACPI for 64-bit Risc-V architectures, and which has only AIA interrupt controllers. For the reasons why we are mandating ACPI for server class platforms, and server class platforms need a scalable interrupt controllers. So that's why we are mandating AIA interrupt controllers, and also that supports MSI. So what that means is currently there are no platforms which can support ACPI today. So all we can do is work with QEMU kind of emulated platforms. So here is the high level overview how we can enable, or what it takes to enable ACPI for Risc-V. Sorry, go ahead.
Just a quick question. So can we, for ACPI spec doesn't require any hardware thing, right? So you can potentially create a ACPI table for, let's say, existing platform Hi-Fi unmatched, and you can test it. Is that correct?
No, the thing is, we need to update the ACPA specification for specific
just for proof of concept. Oh, you mandate AIA in ACPA. Sorry.
Right. Server platforms. Yeah.
Also, I think the focus is only on the server platform, right? So if it was based, he would have to do that click and other things as well. So.
Exactly. Yeah. So here is what it takes to enable basic ACPI booting on Risc-V. As most of you know that EFI system table provides the pointer to the root of the ACPI, which is called RSDP. And I mean, in terms of ACPI, if we can broadly categorize into static tables and dynamic ACPI namespace. In terms of static tables, the RSDP will have a pointer for which is relevant for 64-bit architectures is XSDT, and XSDT has multiple pointers to multiple tables, and depending on the requirements, this can be there are many tables which are kind of optional, and based on features we can implement many of them. But for the just for the basic support of ACPI, we need the important table which is called MADT, is multiple epic description table, which provides the interrupt controller information. And this MADT specification is there in the ACPI specification. However, the internal structures are according to the CPU architectures. For example, Intel will have SAPIC, and ARM will have GIC kind of thing. So similarly, for Risc-V, we need to add interrupt controller related data structures into this specification of MADT. And in this, as Anup mentioned, we have 3 different types of kind of interrupt controllers. So the INTC, the local interrupt controller per heart, we need per heart or per CPU structures. And a logical single Emc node, even though Emc is per heart, we have representation as a logical representation in single node. And Applic domains, which is kind of per chip or per domain, per socket. And apart from MADT, we need other tables like MCFG for PCI Express support, memory map configuration table. And we need another table for timer description for initializing the arch timer driver in the kernel. So this needs some information related to timer. And one more table, which is processor properties topology table. This one is not really mandatory for booting for other architectures, mainly ARM64. However, we are planning to add some extra structures into this, which I will discuss in the coming slides. I need feedback for that also, and make it mandatory for booting the Risc-V kernel. On the right hand side, FADT, there's one more table called FADT fixed ACPI description table, which has a pointer to DSDT. And this DSDT is a special table because it is encoded in AML language. So basically we need AML interpreter to work with this table. This is called ACPI namespace, which gives system information like processors, peripherals, etc. In this namespace, we need to add Applic interrupt controller, because Applic driver comes after the ACPI namespace is available, and that needs a different driver architecture. So Applic will be there in the ACPI namespace, and this one also we need to request a new ACPI ID or PMP ID from UEFI forum, and this one will support _mat method to get the interrupt controller information. In terms of UART, we will reuse the device property method _DSD to communicate the clock frequency and other device properties for the UART. So this is the overall requirements to enable a basic ACPI for Risc-V. Whatever I have marked in red, they all need specification updates for which we need to submit the change request to the UEFI forum. So this will go through the community-driven ECR process, and feel free to provide your feedback. That will be really helpful for finalizing these things. Okay, are there any
how
questions?
are people supposed to provide feedback there and review the specs?
So what we are planning to do is we'll send it to the our tech Unix platform spec alias, and we can get feedback. Do you have any other community in mind?
Sunil, you might also want to touch base upon where the processor features would be there, right? So.
Right. I'll come to that, Anup.
Okay. Okay.
I'll come to that. Did I answer previous question?
How about the APLIC, and this interrupt controller is not, it's different from the which you mentioned, which Anup mentioned.
No, these are all AIA interrupt controllers. Emc, Applic, and IntC are all part of the AIA.
So the Anup's driver needed to pass the ACPI table to initialize his driver.
Yeah, no, driver will support both DT based as well as ACPI based. Anup has developed a DT based driver, and I have done the ACPI based driver. So the same driver will be working with both.
Okay, could we just remove the API description table from ACPI example?
No, this is a mandatory because without that, system will not boot.
Okay, and that means the driver needed to take care the ACPI if we enable the ACPI.
Yes, exactly. Yeah. Driver needs to be ported. Driver needs to be ported to support both DT as well as ACPI.
If I have used the ACPI, could we use the device tree together?
No.
So I think okay. Let me also try to answer this one. Is that the driver will be written for both the ACPI as well as DT. The kernel will be a unified kernel image, which means that Linux, like we discussed previously, Linux will not just care about only the OSI platform. It will be caring about a lot more platforms, which means that the same unified kernel image will be, you can just take that image and give a DT and boot it, or you can boot it through the boot UEFI and give ACPI table and everything and boot it. So the hardware description, be it DT or ACPI, will be chosen at boot time. Okay, so but only one of them need to be provided, not both. So. So just like in ARM, there is a single unified kernel which also boots as ACPI kernel as well as a DT kernel. So.
Yeah, I'm not sure my understanding is correct, but I think if we want to support Windows, we need ACPI. If we just want to support Linux, maybe ACPI is not so necessary. Is that right? My understanding.
Yes, for Windows it's mandatory, but Linux can handle both. So, but for server platform, we are kind of mandating ACPI so that things like Windows can also run on server.
No, but also because the distro that's what distro wants. All the distro wants ACPI for Risc-V servers. So remember, some a platform like D1 or Unmatched, they're not aimed at server, so we don't need ACPI for those. We need only for enterprise classes ACPI because distro wants to have the same environment they have for other ISAs.
Okay, thank you.
Sunil, there is another question in the chat. Since AIA allows Applic or IMSC to be optional, so is the entries in the MADA table are optional also?
Yeah, I mean, Emc is not optional because we are talking about server class platforms, so we have to support MSI. But Applic can be optional if we don't want to support wired interrupts.
Okay. Thanks.
Yeah. Okay. So with that, we have done some proof of concept work, and the changes are spread across QEMU and EDK2 and Linux. In QEMU, as I mentioned, all these tables, mandatory tables, which are required, we had to code, and especially in the MIDT, like I said, all interrupt controller information need to be populated. And in terms of DSDT, like I said, processors, peripherals, and then APLICs, these needs to be populated. And one more thing I have not mentioned here is in the POC, we have done enablement of SMBIOS also. I will come to that, why I had to do that in the next slide. When I come to EDK2, which is Tiana Core, basically for QEMU platform, all the ACPI tables are created in the QEMU itself. So, and it is passed to the EDK2 via firmware config table. So we don't really have a lot of things to do in EDK2. And only thing I had to do changes is to integrate with the latest OpenSPI, which supports AIA, and some of the packages required to support ACPI table installation and SMBIOS table installation. Majority of code changes I needed was in Linux. Currently, Linux doesn't link with the ACPI CA and other modules. So all those ACPI CA and architecture specific ACPI code I had to enable. And all drivers, like I mentioned earlier, which are currently DT based, need to be added. I mean, we had to add support for ACPI based drivers also. The same driver will work with both. Timer driver, interrupt control, local interrupt controller driver, and IMSIC and APLIC drivers. And SMBIOS, which I'll explain in the next slide, will be also was added. And table 44, which is a new thing in the SMBIOS specification, also added. Harish, you had a question?
Yeah, somebody asked in the chat, Rohit asked, will SR80 and SLAT will be provided by UEFI BIOSes for Risc-V?
Yeah, that is a NUMA related thing. Currently, we are focusing on basic enablement of ACPI, and SRAT and SLIT will be in the next steps. Okay, so
I have a quick question, just following up on my earlier one about participation, and it's related to standardization. So it looks like a lot of the work that's being done here is being done to, I guess, a draft standard.
Yes.
And how do we? Is there any risk in terms of the UEFI form and that some of this stuff might get standardized or included into the spec before the Risc-V International has even approved, for example, the AIA spec or the platform spec?
Yeah, so I have a slide, the process to follow. Basically, we need to, within our community, we need to decide on the change request to the ACPI specification before we get into the ASWG forum for review of the change request. So within the community, we will have change request review, and once everything is fine, we will send it to the ACPI group to update the specification. And before sending that, we need to have specification like AIA and all should be ratified. Did I answer your question, Paul?
Yes, you did. Thank you.
Yeah.
Hello. Question. Some pieces do not regarding memory and the injection of memory.
Mike, your voice is breaking. Mike, your voice is breaking a lot.
Sorry, I didn't get you.
Now?
Oh yeah,
it's better now. It's better now.
Better.
Okay, thanks. So there are pieces of ACPI spec related to Risc-V. I can't point exactly to the actual paragraph at the moment, but they kind of seem to be copied either from x86 or from ARM, and they do not necessarily apply to Risc-V architecture, at least as of now. So how can we update this to make them better and less BIOS-centric what the ACPI was in x86 world? For instance, the ACPI tables are pretty much regular memory. They do not require creating a holes in the memory map for them like they do on ARM64. There are also several things very similar to it. How can we fix the standard?
So if I understand correctly, Mike, your question is in the existing ACPI specification itself, there are some problems for every architecture. How do we fix it for Risc-V?
There are problems particularly for Risc-V that probably copied from other architecture. How can we fix it before it becomes widespread and globally accepted?
Hey, Mike, thanks for. Yeah, we looked through and found a bunch of stuff that was like clearly copied from other architectures and not relevant to Risc-V in the EFI, UFI, whatever spec.
Yeah, UFI spec, I think it is updated for Risc-V. I don't think ACPI spec has been updated for anything for Risc-V. This is the first time we are discussing some of these details. UFI spec probably is updated for Risc-V. Some text is there for
UFI. So UFI we got the ECR approved and it's part of the official UFI. It should be part of the official UFI spec by now. It was done sometime earlier this year.
So yeah.
The last year.
Yeah, Mike, probably you can send email to the alias. We can probably take a look if there are any problems with just copying the things from other architecture and they are not correct for Risc-V. I think probably we can edit, raise one more ECR. You can send the mail with details, whatever you find.
Okay, I'll try.
Yeah, thank you. Okay.
So it's okay to change released specs in incompatible fashions in EFI land.
Yeah, we need to see what change exactly, and if it is not.
I mean, it should be a bunch of stuff that's not implemented anywhere because it's kind of not relevant. But it'd be better to get rid of it now rather than be saddled with it like when we're actually shipping stuff.
But I don't think it will be changed like in all the older version, right? Let's say if your version is the ACPI spec version is at X. We'll have a Y
just
version.
set some minimum spec version or whatever for all this stuff and get off our lights.
We have
like
that
likely no one's really seriously implemented the other stuff and is like shipping it in production or whatever. So we can probably live.
Hopefully, yeah. We do have that in the platform spec saying pointing to specific, let's say EBBR version or specific UFI versions, which are all external specs. Same for internal specs as well.
Hey, I had a question. You're talking about how the same driver would handle ACPI and DT devices. I was just curious on a tangential note. Do you have, how many devices have you, DT devices have you kind of ported over to ACPI? And is there like an ACPI source file that I can kind of look at? I'm kind of curious how that's going.
We don't really need to port everything because, like I said, the UR driver, for example, we did not need to do any changes for that because you can send most of the drivers are kind of standard, and if we need something special, we can use the DSD property, which can be used to communicate the properties. So I have not done, apart from the timer and interrupt controller drivers, none of the other drivers I had to make any change for supporting ACPI.
Okay, so we can take it offline if you need them, but I was kind of curious how, if you have OF compatible, if you're matching with compatible strings, how you're going to get it to work with ACPI.
Yeah, sure. We can discuss
that. That would be nice. Thank you.
Thank you. Okay, so one of the thing in Risc-V world is it supports a lot of optionalities, and depending on the implementation, different CPUs will provide different features, and these optional features need to be communicated to the OS. Currently, it is communicated via DT. Some examples are like ISA extensions, MMU type, etc. These are really essential for booting. So the question is, how do we communicate this information in ACPI? Because this is something special for Risc-V. And SMIR specification has added a new table called table 44 specifically for this purpose. And in my POC, I used this initially, SMIR specification, and communicated this hard capabilities to the OS. However, this makes it SMBIOS mandatory along with ACPI just for booting also. So this is where I got feedback from few people that we probably need to add this information into the ACPI itself, not depend on SMBIOS for this purpose. So one proposal I have is there's no, I mean, one thing I wanted to avoid is to come up with a totally new table into the ACPI specification. So whatever is possible, we can reuse. So one table which looks closer to me is processor properties topology table. This specifically currently used to provide the processor and cache hierarchies information for our performance optimization. So it's not really mandatory for booting, but my proposal is for Risc-V, we will add this one more structure into this table and make it mandatory instead of defining a new table altogether. Again, these are things which are still yet to be discussed with ACPI group also. But if you have any feedback, that will be helpful. What option you want to have? Whether we should use SMBIOS or PPTT or a new table altogether.
So there is a question in the chat from Alex. Did we get a concrete request from any of the OS that Risc-V is ACPI is mandatory for a server platform, or is just the experience from the ARM64?
Yeah, definitely it's an experience. I think we got requirements from OS distros also. Specifically, I think RHEL and I think VMware is also kind of interested because they also don't work with non-ACPI platforms. So, and Kumar, you have any other inputs on other OS vendors?
I'm pretty sure this question has come up at every Plumbers, and there's always been some distro folks in the room to say that they need ACPI.
Yeah.
I think same discussion between UEFI boot and non-UEFI boot. There are distros wants that as well. So
yeah, I think UEFI is like a way harder requirement, right? Right, because there's like tons of stuff that you get along with UEFI.
Right.
I think ACPI is more of like a tooling sort of thing, and actually, like, there's huge features enabled by ACPI that could not be enabled by DT. Not 100% on that one though. Maybe there's some distro folks in the room who can chime in. If not, we can talk about it on like a mailing list or something.
Yeah, I would just say, and maybe this is a general situation, it looks like there are a lot of distro folks here now. I would just say, if it turns out that ACPI is not needed to actually make any of the enterprise Linux distros run on Risc-V, it would be really great for folks to basically come out and say that, because it'll help kind of allow people to make some pretty key decisions about what way to go here and what level of engagement with these different organizations is really needed.
Yeah, I mean,
so,
it'd definitely be super awesome to have less device discovery mechanisms to support unless they're necessary.
Yeah, and I would also just add to this that you know, the general conclusion right now is that this is needed, but what we're really missing is we're missing the participation of the distro folks in the Unix platform spec group. And so if there's anything we can do to help increase that, because we really consider you guys to be the main stakeholders, please reach out and let us know how we can help.
So we have already reached out to, I mean, in discussion with Canonical and Red Hat. So we had a discussion and some feedbacks received from Canonical. It's all here. We are trying to get his feedback as well and other Red Hat folks. And we're trying to set up connection with SUSE and other distro as well. So If anybody from SUSE or Red Hat have any comments, it would be time to speak, please. Okay, we can continue. Maybe we can follow up offline.
Yeah, one question I have is, so if people are looking at this after the fact, what's the best place for them to get in touch if there's someone from a distro that has a perspective on this? Where should we point them to?
I think mailing list, our platform mailing list is probably the right place to discuss.
I think we also have a GitHub repo for the ACPI. You can also create issues if you don't feel like joining the mailing list.
Okay, yeah, that is also fine.
So typically, a lot of people who are not generally, a lot of people who don't participate in this mailing list, they directly create issues. That's the typical thing. So.
Okay. I think already time up. So let me quickly go through this next steps. We need to submit these ECRs for the UE5 forum. And the NUMA, RAS, power and performance management, watchdog, all these advanced features we need to work on. And some of the debug tools support we need to do and compliance test, for, especially for the new tables what we are adding, we need to write compliance test. That's all I had. Thank you very much. Again, like Anup said, GitHub or this TechUni, this mailing list we can discuss if you have any questions later. And I have additional slides after this. You can download that, and it gives information where is the POC code and what are the links to the ACPI specification. Requirement specification, etc. So you can go through that later. Thank you very much.
Thanks.
Are there any last minute? Okay, thanks.
No, if you have any question, we can take a couple of them.
Do we have anything in chat room, Atish? I haven't not looked.
No, it's just generic discussion about getting the distro guys on board. So.
Okay. Okay. Thanks a lot. Bye.
I'm just looking for Go to make him presenter. Go, you should have access for present.
Yeah. Okay. I can control it. Okay. It's work. Okay. I want to invite my partner, Fu Wei and Liu Shaohua. Yeah. Let's start. Yeah. They're coming.
Yes, can you guys hear me?
Yeah.
Okay, great.
Okay.
Okay. So, Gordon, should we start that right now? You control the slide, right? Okay, good.
Yeah, I have a controller. Yeah.
Okay, cool. So, first of all, I come from Red Hat and software engineer, and my name is Fu Wei. And so welcome to this session. So now let's focus on what's the problem with D1 Linux upstream. The main speaker of this session are Linux kernel developer Guolen and software engineer Liu Shaohua from Ovina. They are trying very hard to upstream the kernel patches for Ovina D1. In this process, I'm helping them to test the kernel on D1 with Fedora imaging. So as you may know, we have a policy called, Fedora has a policy called upstream first. So our final goal is to make upstream kernel can boot on D1 without any patch. But now we have some broker. So we want to take this chance to explain our solution and hope we can get some advice, suggestion, and help from you guys to move forward. So I'm just a starter here. I'm starter, so I don't want to steal their thunder. So let's welcome Ovin software engineer Liu Shaohua to make an introduction of D1 software ecosystem. So, okay, Shaohua, please.
Hello, everyone. Can you hear me?
Yes.
Yes. Okay.
Yes.
I'm Liu Shaohua, a software engineer from Risc-V team of Owinner. I'm so glad to join this session and share my experience on Linux kernel upstream for Node D1. D1 is the first SoC of Owinner, which is based on T-Head 906 core, which is an amazing Risc-V 64 GCV IP. As you may have noticed that it supports vector extension. Node is supported by several Linux distros like Fedora, Debian, OpenORA, and so on. We are so trying to get more distros supported by interacting with more distro communities. For RTOS, we are also getting a lot of support from different ecosystem partners like Artist-Rad, FreeRTOS, AliOS, and so on. Many colleagues, research centers, and ecosystem partners are using D1 on different interesting projects. Like Rust SBI, OS kernel, and security. For example, OpenCV and NCNN have been ported on D1. Okay, let's talk about the most interesting stuff. How does a Linux distro boot on D1? Let me use Fedora image as an example. As you may get from the boot log, SPL is the first state bootloader. Then it loads U-boot package with a bundle of DTB, OpenSBI, and U-boot. Finally, U-boot loads grub with boot Fedora like UPC by grub config file. For the status of this firmware, we can just use the upstream version with a few patches. Now, let's focus on Linux kernel. For upstream kernel, we have made some drivers patches and notice that there are some kernel developers are working on D1, especially Samuel Harland from Boeing. Thanks to T-Head engineer Goran and Fuwei from Red Hat, we have boot Fedora on D1 by upstream kernel with some patches. But Linux is an open source project. We would like upstream all the patches. We need to make mainline kernel can boot perfectly on D1. So we would like to work with you to upstream the patches as soon as possible and contribute to Risc-V ecosystem. Thanks. Okay, next, my partner Goran will introduce the next part.
Okay. Hello, everyone. Now let's talk about what D1 needed in the Linux Arc Risc-V. After Linux Arc Risc-V supported D1, all drivers work of D1 would have a good fundamental base. And that was the purpose today we needed to discuss. Okay, here is the agenda. Firstly, I list six points of D1 here that needed put into the Arc Risc-V. The first four won't block D1 bootstrap, so they are not the highest priority issues. And we just have a quick review on them. And mentioned here, we just hope audience could have a total view of the D1. Then is the fundamental pages for D1. The most controversial topic is about the custom-based, page-based memory type. Let's focus on it in this meeting. Okay, Vector .7 above, as you can see above, is the difference between the Vector .7 and the 1.0. 1.0, yeah. VLAN, the VLAN in our hardware is the 128, which I have tested on our hardware platform and modified the QEMU platform. So the only difference is the VLOAD and the some bits changed in the CSR. The Vector, the final Vector have rectified recently, and we will send a patch after official Vector implementation merged. As you can see, there is not so much gap between 0.7 and 1.0 for context switch. After green times patch set merged in, we will use alternative framework of aerator in vector.s to patch text. Also, the CSR register need global variables to init. Oh, and I would say all next generation T-head C9 series processors would follow the rectified vector spec, but we want D1 get merged in upstream Linux. And next is about the performance monitor. Yeah, D1 has its own performance monitor, which implemented 2 years ago, and now the OS spec have some related spec of the PMU. But if you want to try perf recorder with the hardware event, you can use this patch I have listed on our presentation. The coding needs to be reconstructed before upstream to follow the new infrastructure as possible as we can, and the any feedbacks are welcome. And another thing is our TLB hardware broadcast synchronization. And next is the okay. Okay, sorry. And next is the Emc Cache synchronization acceleration in D1. T-head C900 series provide custom Emc Cache synchronization instructions. As you can see, always based on the cache line, yeah, and we can invalidate by the virtual address index and or the physical address index, and then we need a broadcast synchronization to flash all pipelines in all hearts. Yeah. The right side is the VDSO patch, which could improve the performance of the OpenJDK's JIT scenario by preventing system call and IPI. Yeah. And I think the Risc-V would define his own maybe it's the same old instructions to handle the Emc Cache synchronization, because from the computer science we need a high performance Emc Cache invalidation mechanism. Yeah. And the D1 is using C906. That is a cost down processor IP. Of course, with the high performance implementation, which needn't invalidate the iCache lines, and just the synchronization pipeline is enough. Currently, alternative is only for VM Linux, but D1 for the iCache synchronization, we need a alternative framework in the VDSO to support more platform in custom implementation. And the next is the TLB hardware broadcast synchronization. Yeah. Fortunately, current Risc-V Linux is now using a unified SID mechanism between all hearts, which was inspired by ARM64. And this software design is very suitable for TLB hardware broadcasting mechanism. And T-Head C900 series provide TLB hardware broadcast instructions, and we could use an error mechanism to patch text, just like Sci5's flash TLB page, this kind of thing. And why we why we added the TLB hardware broadcast in our processor is because from our previous generation processor, C800 series, our processors are designed with the hardware broadcast TLB shutdown, and the T-Head C900 series was just inherited from that. Also, it could be disabled by CSR. Okay.
Can I just make one comment on that last slide, or ask a question perhaps? So
okay.
I think the alt flush TLB page was added due to an errata at Sci5. It wasn't the result of like an intentional design decision. Just so I understand, these instructions here, these are intentionally required here as part of custom non-Risc-V features for this T-Head C906 design. Is that right?
You can think our TLB hardware broadcast synchronization is error stuff, and it's just to improve some performance for our processor. We also could support native Risc-V local TLB flash. So I mentioned the Sci5's implementation here is just to show you how could we put this in the Linux. We just put in our error infrastructure. Yeah, make sense?
Thanks.
Okay. Okay, let's focus on the fundamental patches for D1 bring up. It's the most important one I want to talk today. And the previous 4 points I have mentioned, they are just improve the performance or enable some function additionally. They won't block the bring up of the D1. Okay, and if you want upstream kernel make work on D1, you at least need here. I have listed the 6 patches. Yeah, recently we rebased this patch on the latest version kernel and tested on the QEMU and all our hardware platforms, including D1. You can try it by the Fedora wiki. The first 2 patches are for custom page-based memory type. The next 3 patches are for the DMA synchronization operations. And the last one is just add the Sunxi SOC in kconfig. Yeah, let's review them one by one. Yeah, First, I want to talk about is the custom page-based memory type. And just you can see, and the left is the latest standard page-based memory type proposal. Yeah, and the right side is the D1's page-based memory type. Yeah, in the higher speeds. Both the standard PBMT and the D1 custom PBMT all use the higher speeds to determine memory type, but encoding is different. So both of them, so all of them would break the rule in current spec that the higher speeds must be zeroed by software written by the spec. But the standard PBMT keeps the higher speeds zero with the normal catchable usage, but D1 must set the higher speeds with the normal catchable, which needs patch the Linux COM code, yeah, such as the memmap.c. And you can, my first patch is deal with that. And because of the normal catchable type, higher speeds non-zero, D1 also needs a very early aerator init before the setup VM. Okay, so that means the standard PBMT design is much compatible with the current design, but the D1's one will cause some another additional effort to enable it. Risc-V page table. Firstly, how we okay. Firstly, we need to add a custom protection map init for D1. Why D1 need this patch? First, D1 change normal cacheable memory type higher speeds, which I have mentioned in last slide. If we put global variable in the traditional the protection definition, memory map definition, and then it causes a compile error with the memmap.c. You just look at right side. It's very simple because it's static initialized, and if you put a variable in this macro, then it will cause compile error. Standard PBMT needn't dispatch because it keeps higher speed zero with the normal catchable memory type. Okay, so it's just for the D1. And the second patch is the aerator PG table at a customer SV PBMT. Actually, both the standard PBMT and the D1's PBMT needs this patch, and but D1 also need earlier initialization, okay, because we changed the protection map. Here are issues needed to discussion. One, the first is how to determine the standard, customer, and the non-PBMT. Yeah, in my patch, I utilize the vendor specific vendor CSR, vendor ID CSR to determine which the vendor is, and then we can initialize it. And yeah, and the second is about how to compatible with the global DMA pool style. I mean, such as the Starlight, yeah, Starfire, Big V, yeah, how to say that? Yeah, the Starfire board is built on the DMA pool style, not the PBMP style. So we may enable them together in current Risc-V. Yeah.
So two things. First, I think we can rely on the DT. That's just my opinion for the standard PBMT, and then D1 would be an errata of the implementation of the bits. And then if the DT property is not available, then we know that there is no PBMT. For the Beagle 5, Beagle V, where the DMA pool style, global DMA pool style will probably use the DMA set uncached. And then that's where I responded in the mailing list as well, where we can have a platform hook, which from the generic code, which would let us know that whether this platform supports directory map. If the directory map is supported, that means and that would be enabled only if PBMT is supported, either standard or custom. Because currently the generic code is based on all the macros, but for the Risc-V, since we aim to have single def config for all the platforms, like no PBMT, custom PBMT, standard PBMT, and global DMA pool, so we can't rely on the macros because those configs, sorry, not macros, configs, those macros will be enabled for all the platforms.
Yeah, so I'm not super worried about digging into the implementation yet. Obviously there's been a bunch of stuff in there that's not okay, because like Atish is saying, it defines, I used to turn my video on, it defines whatever it's called, pound defines and that sort of stuff that are specific to this device and will not function on other devices, right? Standard devices. So that stuff we're not accepting. I think everyone's on the same page there, and that there are mechanisms to fix it, right? My bigger question is, are we taking support for devices that very explicitly are incompatible with the specifications? Right, because the specification clearly says that these bits are reserved, right? And there are things in these bits that's incompatible, right? Now we got the Risc-V Foundation saying that it's Risc-V and sending folks boards and all that sort of stuff, which is very unclear as to whether or not this is really a Risc-V design. And that's my worry here.
Actually, the PBMT is is similar to the current.
Yeah, but similar is different, right? The whole problem is that it's different, right? And what's there, the spec as written, at least when I tried to look through this, had these bits as reserved, right? That means that compatible implementations can't do what they want. That's kind of the same.
But when the standard PBMT come in, the standard PBMT also will break the role of the reserved zero, isn't that right?
So, because the reserved bits are reserved for standard stuff, and from my understanding of it, right? So the standard can use those, but other stuff is not supposed to put things there because they might behave differently later, right? I mean, that's the same thing we had with the interrupt ID bits, right? Which are all reserved and then got repurposed.
What Go is pointing to is, so it was a reserved bit until SB PBMT gets merged in, right? Once, let's say we have 1.12 with SB PBMT in, it's a standard implement PBM. Those bits are reserved. Those bits are defined for PBMT, and then we treat that D1 implemented it wrongly. It's a gray area, but it's your decision.
I mean, what I'm really worried about here, and this kind of is the same as the platform spec discussion, right? Is I don't want there to be us to just get roped into supporting random stuff that did not follow the ISA, right? I get there's going to be errata, but if you look at the process by which the errata we currently have in there landed versus the process by which these did, it's obviously very different, right? Because these are in there as purposefully designed in features with things that are incompatible with the ISA, right? As opposed to the S-Fence VMA address not being handled correctly, right? That's okay, that's a bug, right? And we can fix that bug by not adding any customly defined bits in there, but by just using standard stuff, but restricting the set we use to a subset of the standard stuff on the systems that have broken behavior, right? That's like way more palatable because at least we know what that standard stuff does, right? It's in the standard. And the rule of don't use this particular flavor of that instruction because it's broken is a very understandable situation to be in, right? Like I'm worried about like the semantics of these bits bleeding over into drivers. Like where the bits are, I don't really care that much about, right? What I'm really worried about is like the difference between the Risc-V Foundation semantics, which will hopefully be well defined. I don't know if this got finished yet, but hopefully we will have well enough defined semantics that we can reason about the memory orderings and whatnot when those bits are set, right? As opposed to this other mapping of bits, which is specific to this processor or processor family or something. I don't even know, right? I'm worried about those bits starting to bleed over into all of the drivers and whatnot that we support, right? Like that's my big worry.
Okay, and what you worried about is that means the following the vendors won't follow the ISA spec, and they will implementation their custom bits with this backdoor mechanism. Is that
like
right?
I'm less worried about the definition of the bits. Like if we had the same semantics for these 4 regions and the bits were just different, I wouldn't be that worried about it. That to me seems like a perfectly reasonable errata thing, right? Because maybe someone screwed something up. But in this case, like the definition of these bits is different, as far as I can tell, than the definition of the Risc-V bits. And the Risc-V bits are really what we want interfaces to be written to, not these orderings.
I mean, if we just put them in the aerator and just keep them in the aerator and won't export to outside, is that all right for you?
I guess
we just put them in the aerator in the alternative framework.
Yeah, my worry is other kernel code getting written to this interface as opposed to the standard interface. Right, and if we're providing like these orderings to folks, then in practice, kernel codes can get written to that. Now, maybe there's nothing we can do about that. That's just how it works, right? Yeah.
So what about the suggestion you could give us that how to let D1 upstream with the Risc-V Linux?
Yeah, so there's a thread going in the chat with Vineet. So my argument about waiting for the specs to freeze is that if you want to implement a feature that depends on those specs, and you want the you want that feature to be like compatible and maintained in the long term and whatnot, then yeah, like you have to work with the spec committee in order to make sure that you guys are aligned. Right? If you go off and do your own thing to add some feature, then there is a chance that software won't work. Right. Now, the wrench that's being thrown in the works here is that these are the boards that are getting delivered to everybody as like the example developer board, and like how do we tell everybody just like, oh yeah, sorry, like your hardware is not supported, despite it obviously being the preferred hardware from the Risc-V folks.
Yeah, there seems to be this kind of split brain thing going on where some of the folks I've talked to are saying things like, well, the non-privileged side is compatible with RV64i and they didn't diverge there, but they clearly did diverge on the S spec, and so I think folks at the foundation, my understanding, are reevaluating the whether it makes sense to keep doing what they're doing now. I don't know what the practical outcomes of that decision will be, though, or those
yeah, I mean, to me, that's the big issue here. And like, if this is how Risc-V works, and you can do whatever, and it's still a Risc-V design, then we'll have to figure out how to deal with it, right? And that may mean just, sucking it up and dealing with all the resultant chaos, but it's going to be a lot of work.
So Palmer, who was the last say? Is it like, do you want RBI to conclude on anything, or like we need to reach a conclusion, right? So
yeah, no, that's totally understandable. I'm not really sure quite what I'm asking for.
I mean, isn't it also significant that this is the only mass-produced SoC, and also the only mass-produced SoC that's really on the horizon? No one else is doing mass production for an SoC that we could actually build Linux systems with. So I mean, there's that practical consideration, right? It is special, right? Like no one else has done this, right? And I don't think for it will be like this for a while.
There will be two.
Like that's a double-edged sword, right? Because if we start like for the V0.7 stuff, if we start providing that to user space, that's what everyone's going to write their code for, because that's what folks do, right? And like that is what it is going to end up supported. And then we have this other problem of there being a second 10%. Right?
Yeah, I think this is one of the big challenges here is that for the T-head guys, whether you guys know it or not, like you're basically creating a risk of forking the architecture that's in a direction that's not where the Risc-V Foundation is going right now. And I guess I would just want to ask you guys, and I know you can't answer, but do you really want to do that? Because I think there's a lot of value in aligning and trying to align to the Risc-V specifications as they're defined by the Foundation.
Yeah, this is why like I don't really know what to do, because it's not really our job as kernel developers to.
But are we going to wait like 6 months or a year to have a chip that supports these standards that aren't even frozen yet? Like if we're just going to be QEMU for like another year.
I don't know, that's the problem, because if we do that, right, like then suddenly this is all irrelevant.
I mean, in my mind, Allwinner gets a lot of credit because they're the only ones that have taped out a chip that's like mass produced, right? No one else is willing to do that thus far.
Yeah, for some stuff like the vector stuff, there was a lot of confusing messaging from the Foundation as to what should be done. Like, and that, like, I do feel bad about that, right? Sorry.
So I think we have to differentiate between two different things here. So we have the page tables and we have vectors. So for vector 0.7, there is a solution on the horizon, which is going to make it an X extension. So it's not going to be called a vector, but a vendor extension. But the big problem here is really page tables, because it really is at the heart of what the kernel does. And how we can enable that, I think we don't have to worry that much about creating a precedent, because these chips were designed way before all the standardization work that's going on right now and the branding work. So we're really in a phase of where we're moving from what was before into what the future brings, and there can be a way stricter way to deal with it than what we had in the past. And I fully agree with Drew here. Waiting 6 months or 18 months for actual hardware isn't really a good choice.
I'm not quite sure I understand that point of view. I guess from two different, I would have two comments. One is I would say I don't understand how merging changes that are intentionally incompatible with the frozen Risc-V specs or ratified Risc-V specs is not setting a precedent. That's one observation I would make. And I think the other observation along those lines is, I mean, this idea about waiting for hardware to be released. I mean, this is exactly the same situation that anybody that ships code for ARM or for x86 has to deal with, except that people don't get that early glimpse of what's in progress and what's being discussed. In general, if people are writing to ARM 64 code or x86 code, they're not trying to get their code merged before ARM or the x86 guys actually release and approve the specs. So to me, I think that's kind of the analogous situation.
Paul, I must say I do agree mostly with this, and every time I'm having this discussion, I feel a bit uneasy about the implications of moving this forward. But at this point, it's really it feels like we're between a rock and a hard place, especially with the sport being very widely available, the foundation shipping it to users, and the question on the path forward for me is more, can we enable that in such a way that we do not burden the spec compliant implementation, and that we quarantine it and modularize it in the kernel, and less about the principle, because unfortunately in principle I tend to agree, but I'm trying to walk a more pragmatic way on this one.
Yeah, I mean, like, I think that's the problem here, is that it's not the situation we want to be in. I don't think but like, how we have to live with it, right? Because it's real world, right?
Yeah, and you know, I think that's the challenge for us. I think, you know, we're just like everybody else that hacks Linux. You know, we like the idea of upstream Linux booting on the hardware that's out there. I think, you know, I've talked with, just talking as the maintainers, you know, we all like that idea, but we also, I think, have to be really careful with this risk of fragmentation. It's one of the first things that folks bring up about one of the negative side of Risc-V, and to the extent that this fragmentation becomes starts to get out of control, it doesn't only impact us as maintainers, it impacts, I think, the entire Risc-V ecosystem and the value that's in it. And so I think whatever we do here, we just have to be really careful and sensitive to those considerations.
Okay, go. I have one question for you. So, is there a way to avoid altogether this PMBT, your custom PMBT? Like, basically, if you go ahead and like have a custom compatible string in the impacted devices, and then have a custom flush, like how many devices are impacted actually?
All devices need the PBMT. Yeah,
But
without PBMT,
it's USB. How much? MMC. What all
USB
devices?
Ethernet. So
yeah, MMC, GMAC, MMC, GMAC, all need it to work with to DMA synchronization.
Immediately, so see, the DMA sync part is okay because the CMO is being frozen, so we can always
I know. Yeah,
trap in.
I
So
mean
that one story can be addressed. The biggest challenge is the custom PMBT. So like if we go the crude approach and like change the drivers itself and put your errata workaround in the drivers itself,
I don't think that will fly.
I mean,
This is actually the worst idea, because I don't think these drivers are specific to the SoC.
Because generic drivers, so
because
they
otherwise
will be used on future and compliant Risc-V devices.
I don't think driver maintenance will ever agree to that. So
yes, the other thing is if you the only downside of the custom global variable based approach what Geo is seeing is that it will impact all the future platforms which are compliant as well, because now you have added a load store in the path, right? So
okay.
Yes, I'm not super worried about that, because like we can hide enabling the errata behind a kconfig, and then it will only exist in the realm of systems that care about being compatible with this as a performance hit. Right? Like that doesn't seem too scary.
Okay.
Yeah, like when push comes to shove, like any errata is going to have some overhead to be swapping between it and whatnot.
But then, Palmer, then this platform won't be covered by a unified kernel goal that we are trying, right? So people will have to build the kernel separately for this thing.
No. Like the big difference here is that kconfig must be turn-onable with all of the other Risc-V kconfigs. It doesn't mean that kconfig cannot be turned off, right? Like you can always build kernels that will not boot on a system. There's way too many kconfig options.
Okay, you're saying the other way around, like have it enabled and people will disable it.
Yeah, like if I have to flip a switch that says either boot on the standard stuff or boot on the D1, like that's not cool, right? But if I have to flip a switch that says boot on the D1 or don't boot on the D1, right? You know, boot on the D1 and standard stuff, or don't boot on the D1 and standard stuff, that's fine. Like, because all the drivers are necessary, right? Like all the other errata are done that way, right? Like we're not going to rope people into including every bit of support for every SOC into every built kernel, right? We're just going to allow them to do that, and then def config will probably support the common ones. Sorry.
I'm just worried that the common distributions will then always enable that if we have massive exports out in the wild. I'm just wondering.
But that's their choice, right? It would probably go in def config, as does the support for the other common SOCs, until this thing falls off. But at least folks who want to build like an embedded system that doesn't have this don't have to get roped into that performance.
Yeah, I kind of agree with Palmer. Like def config will have all the options, and then distros or individual developers can go ahead and disable some of those config.
Yeah, like def config will have the set of options that kernel folks want, because that's the rule, right? If this is a common board, it'll probably be on, because folks will have to test it. I actually don't have one, but at some point I'll probably end up with one, right? But like that does not have to persist into all kernels and forever, right? That's a big difference.
Yeah, distros can choose not to. If they don't want to support D1, they just disable that config.
And specifically, if distros live in a regime in which the D1 does not make sense, right, then they don't have to take the performance hit.
In terms of code and maintenance, I'm a bit worried, because we're actually dragging that code and df-dev path into all of the page table handling now.
Yeah, I mean, so obviously what's in the current patches is not okay. We talked about that but I'm not convinced that the actual like juggling of the code is the maintenance problem. My worry is, number one, the precedent, because that to me seems like a very dangerous precedent to set. We kind of can't do anything about that because the foundation is going that way, and it's not really our job to prevent the ISA from fragmenting. And my other worry is the rest of the kernel interface is starting to be written towards this. But again, I don't know if there's anything we can do about that.
Okay, and
could we use one of the code patching paths, either putting what static called over or alternatives in order to hide the penalty?
Yeah, I mean, that's why I'm not super worried about discussing the performance implications right now, because there are many, many things that can be done to deal with it, right? And I haven't looked enough in there, but if people care enough to make this perform fast, then I'm confident that something can be done, right? So like, I'm not super worried about that.
But wouldn't that also hide the API fragmentation then? Or the interface?
No, because the API is like, what orderings do I get enforced when I ask for the generic kernel orderings? Because Arch code right, and drivers and whatnot are frequently written to those internal interfaces, even if they're not supposed to be. Because Arch code can't be. But anyway, that's my worry, right? And then we start bringing up all this stuff, right? And like it doesn't work when we try to bring up the standard stuff. It's kind of the same as the worry about like the V0.7 stuff bleeding over into user space.
Again, I'm wondering if we could get the standard stuff in and use it as the prototype, and then hide this behind the code patching path.
There are no implementation. Whoa. There are no implementations of the standard stuff. And it's not.
I guess we can't move this in unless the standard implementation is here, which just increases the pressure on the standard one.
Yeah, like at a bare minimum, I want the standard stuff to be there so we can describe our interfaces in terms of the standard stuff, and then implement those standard interfaces to the best ability that we can on the D1, right? And if that means that there's a little bit of an impedance mismatch and sometimes you need to upgrade something, well, that's what happens, right, when the standards don't apply, right? It's the same as all the other errata, right? We do them by providing an interface that's as close to the standards as possible, and then the vendor gets to live with the performance hit when they do something broken, right? I don't see a problem there.
To be honest, I'm not sure that describing this as an erratum is even accurate. I mean, it's to me, it's clear this isn't even these aren't errata. Right?
I think at a philosophical level, it's not an errata, because an errata is a bug and this is a feature, right? So it's not an errata, right? My worry is that that's kind of not our battle to fight,
Yeah.
Because
If we
that's
come
really
back
handy.
to the fact that an error usually results from somebody holding the specification wrong, I think then we have an errata here.
I don't think this is a mistake. I think that's the key
Yeah.
issue.
Like, can we call x86 a Risc-V errata and have to support all of those systems? like, it's nuts.
And Palmer, and I would say when the standard PBMT come into the Linux, that will cause another type of the page table bits definition that will bring the variable into the page table also. So so why we couldn't put error ATA setup VM for D1?
Yeah, again, like I'm not.
You have said you worried about that the following vendors would have the backdoor, and then they want to follow
worry.
the ISA. Yeah, that's your worried.
Like we will figure out a way to implement the things that we need to implement in a performance fashion.
But you know, when we design D1, there is no specification about the PBMT or the how to deal with the DMA concurrency synchronization.
Yeah, there is. It's be concurrent.
Yeah.
That's what everybody else did, and their systems work. Well, actually, they don't.
There were PMS. You could have used PMS, but so yeah, PMBT is like a addition.
Yeah. You know the the O-winner is from the O-winner's previous SoC is designed in ARM, and they are all PBMT type.
Yeah, I get that there are many things that are in ARM that are not in Risc-V, and that
So the SoC is based on ARM. So that's why we choose the PBMT to solve their problem, because their old drivers is based on the PBMT. So we needed to provide a PBMT.
So like I think Atish was saying, like the PMAs were the proposed way to deal with this in Risc-V, and other systems have non-cacheable memory via PMAs, and those can touch non-coherent devices. It's like there was a mechanism for doing this. You picked a completely different mechanism. I get that mechanism looks like the ARM mechanism, and we're going to have it soon. I kind of lost track of exactly where the specs are because everything's getting released right now. But like it's my point is that it's philosophically not an errata, right? It is a conscious choice to do something in a way that was not compatible.
Okay. Palmer, I have two questions for you. One is that like this will be a direct exception for the Risc-V patch acceptance policy, right? And the other question is, okay, we go this route, add this kconfig option, and also put this in an errata. But then this should not set a bad example for future things, right? So this should be have some timeline, and after some years, like it should be removed actually totally from the kernel.
Well, removing stuff from the kernel.
Yeah. There will be one guy who will be still running All-Winner D1 after 10 years. So he's like,
But once it's in forever-ish, right? That we're not breaking those rules. We're already breaking enough rules.
So I think there is no point in discussing why it was done. It's already done. It's in silicon. We can change it. Now, whether we upstream it or not.
Yeah. So, I mean, at a bare minimum, we have to sort out what the standard stuff is going to look like and whether or not it's possible to,
So I think one thing I want to comment on the standard, like SB PBMT is already in public review. So it will definitely be frozen in a couple of months.
Well, that's what I was going to ask. Is it frozen? Because it's super gray right now as to what's frozen and what's not frozen.
So, okay. SB PBMT and CMO, both are in public review. Public review period is 45 days. So in 2 months, hopefully by summit, it should be frozen. Unless
but they are not frozen because other things
not right now.
Other things get frozen before public review. Some things are getting frozen after public review.
Well, actually, according to the process and the milestones, it gets frozen before it goes to public review, and it is approval ready once the public review and all the comments have been in.
So are these frozen or are they not? Maybe we can do this over email because I really just like
we have to do this over email because I actually have to go back and read those announcement emails again.
Yeah, so this is a key process issue with the Risc-V Foundation right now, or with Risc-V International, which is there has to be some public documentation of these processes, and there has to be some public list of what is frozen and what is not.
I don't personally care that much about the process, but I at least need to know what currently constitutes the ISA. Because, it's nuts.
The process is publicly documented. I can pull up that link because I was looking at it just yesterday again for other reasons, and it is an approved policy. But that does not necessarily mean that with all the rush that's going on this year, and at the moment, people are necessarily sticking to the process or to every word of the process.
Okay, well, we're on break. Maybe let's do this over email, because otherwise it's just going to be us all speculating, because I cannot keep all the things in my head because there are way too many.
So I'll send a link. So I think in the past also I've shared the links for the process, and I'll send an email again with the updated documents. It's in the public domain, so I'll just share it in the Linux kernel mailing list. And to answer Palmer's question, it's not yet frozen, but it will be frozen by a summit unless the world goes on a wheel.
I would ask the Palmer that you forbidden any modification on the page table bits. That means you forbidden any error eta in the page table bits.
No, I'm not. Like my issue with describing this as an errata is that at a philosophical level, it is not an errata. Right? That's the problem. Right? Now, the errata framework could be used to fix this problem. I guess we have to look at the standard and what these things are and sort out. That's sane.
Okay, I would say the standard PBMT is soon ratified, and all things is concluded. That it would keep the highest bits 0. That means the standard PBMT will add some fallback, some callback. Just follow the error eta is enough. That means we could detect the DTS using the DTS to determine how standard the PBMT is or not. Yeah.
I mean, we can totally sort out how to probe this stuff. That's a solvable problem in many ways. So
but D1, D1s and the D1s just need some earlier initialization. I mean, and my first patch and part of the second patch will do that, and this of stuffs could be approved by the Risc-V Linux.
Yeah, so I'm not worried about the early init of errata. Like the errata will be initialized early enough to make them fix the problems that exist, right? Like we've done that in other places. Generally we don't carry around code that doesn't have users. So until there is a use case for errata being initialized that early, it doesn't really make sense to reason about how to initialize it.
Yeah, I think what Palmer said earlier, like implementation is not the problem. We can implement it in a cleaner fashion. We need to answer that philosophical question. If any platform has an incompatible implementation, whether that should be considered as an errata and allowed upstream, right?
And maybe you think this is just a hardware error eta stuff, not incompatible stuff. I mean, you want to say Sci5's page fault is incompatible.
No, but they did not use the other 2 bits, right? So okay, if you would have been used only to those 2 bits, it's just that the purpose of those bits are different. Agreed. But your implementation uses 4 bits while the standard uses 2 bits, right? So the other 2 are still reserved while D1 uses those bits for some reason. Correct?
So the heart of the issue, Guru, is that these bits were marked as reserved, and not reserved for vendor use, but reserved for future standard use. And that's why this discussion is going on in this direction, and why the specific wording is being used by people. It has to do that these bits were always reserved for future use.
And also except those 2 bits that are used by PBMT, the other 2 bits are still reserved. Like even after PBMT is merged, the other 2 bits are still reserved, which D1 uses for its PBMT, custom PBMT.
Yeah, I mean, this is kind of the problem here. And this is very purposefully not to spec, right? As opposed to something like, not properly respecting some orderings in SFNCMA, like the other board does. Like that's clearly a bug, right? And bugs happen, we have to live with them. But there's a big difference between people who tried to implement something to spec, right? Like the Drew's board, the sci-fi one, had some provisions for non-coherent stuff based on the PMAs, right? Like they tried to do it to spec. Oh, sorry, Atish. We're done. I think we ate our break too.
We have to go on to the next one. So isn't there going to be some kind of BOF about this?
Yes.
Somebody, could you talk about that?
Yeah, we'll talk about that.
So I have requested a BOF. It's on the Friday. It's on at 9:15 a.m. PST to discuss this and other things in the platform. So we can continue discussing there. I think David already shared the link in the chat. It's along with all other BOFs. So take a look at the BOF schedule.
Cool, thanks guys. We'll talk more. We'll figure something out. let's go talk about iPhones.
I think this one will never end. So
I know, right? All right. I'm gonna take a break for like a minute or two. Hopefully, Kito's here.
So Palmer, and you means if the standard PBMT rectified, and also the D1's PBMT couldn't be.
So first of all, frozen, not ratified. Ratified doesn't matter. Frozen matters. Frozen's the rule, because frozen means that the foundation folks are saying they're not changing. Let's not eat Kito's time.
Guys, can we take this to the BOF?
If the standard PBMT frozen, and then the D1's PBMT could be again send patch to you, and you will review that.
Guys, let's just take this to the BOF. We're already.
Yeah, let's continue it on BOF during Friday. Okay, we are already eating Kito's time. Kito, I have made a presenter, so you should be able to switch back to your slide.
Okay.
Yeah, let me try.
Thanks, Go.
Yeah.
Okay, turn off video. Yeah.
Just make sure, could you see my screen? Oh. Yeah, could you see my screen?
Yep.
Okay. And it's start or wait for you more break time?
I think can start. You're already.
Yeah, you better go ahead and start.
So.
Yeah.
Okay, cool. Wait me for a minute. Okay. Okay. Hello everyone. I'm Kito Chen from Sci-Fi. Wait, I forgot to open my webcam. So okay. Hello everyone, I'm Kito Chen from Sci-Fi, one of the Risc-V GCC port maintainer. And this session, I would like to talk about the state of the iFunk. The title is the puzzle for the Risc-V iFunk. So the session will consist with 2 parts. First half is more like the toolchain stuff, how iFunk work and what toolchain need to do, and what we are missing for toolchain implementation now. And the last half is, I believe, is more like Linux kernel and the GDFC related. The design of hardware capability too. Let's kind of cross component, and I believe here is the best place to discuss this issue. Yeah, so here we go. So first, let me talk about what is iFunk, but in fact, I am not intended to describe the detailed implementation for the iFunk. Just give a very high-level overview. And those text describer from the GDVC's wiki. So the key idea is iFunk give you a mechanism to selecting the best version of function for current platform depending on the resolver function. And most of the stuff are done by the GDP infrastructure, and the behavior is also well defined by the architecture, since the iFunk is already widely implemented in many other architecture like the x86, ARM64. So ideally, we don't need too much work to enable that for Risc-V in theory. Yeah, but again, the real world isn't so beautiful, so there is why there is a session to discuss this. So what's the state of the Risc-V support for the iFunk? Yeah, Risc-V have some basic support for iFunk now. As mentioned on the last page, we have GDVC iFunk infrastructure, and we also have our own relocation, which is the minimal protein for the iFunk, which is added by last year. And so do we have a workable proof of concept? Yes, we have. The Sci-Fi has an internal implementation, but it's not a complete solution yet from my point of view. So again, that's why here is this session. Yeah. And however, I believe we need iFunk very soon, since the vector extension, beta manipulation, crypto extension is coming. And I believe this time is true. The vector extension 1.0 is really has an official tag there. So vector,
and it's frozen. I talked to Andrew about it. It's actually frozen. Like,
yeah.
So it's,
anyway, I believe this year is true. I know many people have heard of that many years, but
it says it's frozen and it's tagged, so there's no way to go back now. Finally live with it.
Yeah, so I believe people will desire to have their own optimized routine for those C library functions. For string compare is a very good example. We may have a generic version for the baseline ISA, and optimized version for beta manipulation, and another version for vector extension. Okay, let's sounds great. It should work, but what we are missing for the several part. To me, I think there is three major issues there. First two is the tool chain implementation part, and the last one is the kind of Linux kernel stuffs. So let me describe first the issue first. We don't have mechanism to disable or enable specific extension there. So why it's a problem? Imagine that we want to build a GDVC with RV64GC. Okay, now we want to build a vector optimized version string compare with RV64GCV, and another version for beta manipulation optimized version with RV64GC underline ZBB. Okay, how to build that? Oh, okay, the most straightforward solution is let's hardcode the C flags in your GDVC make file fragment. Oh, and RGC for RVC for GC3 for the vector version, and another for the beta manipulation version. Okay, that's not good solution, but that's what we did in our proof of concept, and of course it's worked. But I believe it's not a scalable solution. what if we want to build in a GDC without C extension? And what if for the RE32? Oh, of course, you can build a very terrible long condition check in your Make file. That is possible, but I believe we don't want to see that, and it's impossible to maintain, I believe. So what we have now is, in fact, we have something like that. We have the option no RVC and the option RVC to disable or enable RVC extension, but we don't have an option for all other extensions. So yeah, we can only have a special version for C and then no RVC. Yeah, it's not announced for now. And another problem is an arch option could be a solution, but it's kind of harder to use because an arch option need to specify the full architectural string in canonical order. So so you mean we mean using some simple string concat to make the build option work, but it won't work well due to it mean not satisfy the canonical order. For example, your arch is RV64 GC underlie ZVB. Then after this computation, or you result in an embedded ISA string, and you can build your GDC now. Okay, so currently we are considered to extend the compilation flag. For example, add some -n arch equal plus v to append the new extension, or modify the enarch syntax there. Suppose some modifier like plus to enable specific extension there. Or we have an ongoing proposal here is do not require canonical order in the enarch option anymore, since the order is to me, I think is not really easy to maintain, especially when we have bunch of extension now. Yeah, how many extension I will talk about later. You will see it's very long list now, the extensions. So currently we have some proposal is ongoing for the extend the option no RVC and RVC to all other extensions. It's kind of introduce new syntax for the option. The option arch comma and the plus extension or minus extension to enable or disable an extension for specific extension for foreign core region, or just reset the ISA string with the full ISA string, and it will work with the option push pop. Yeah, so it will work fine with most existing code. Yeah, and I expect this could be supported in near future and could be used to implement in the iFunk. So next one is about the C label. We have the proposal for the assembly code solution, but we don't have C or C++ solution yet. Other target has provided targeted attribute to specify an option, function to compile with the specified target option. For example, SSE, you declare a function SSE underline func with an attribute target SSE3. Then this function will compile with SSE3 no matter it's enabled by your CFX or not. But unfortunately, yeah, Risc-V didn't define that attribute yet. But to me, I think it's fine for shorten, since we can optimize those functions in assembly file first. But I believe we must have a long-term solution to define it to make it easier to write in iFunc functions. And we don't have any proposal for that yet because I think this feature is depend on the last page I mentioned, the adoption act directive, which is still ongoing. Yeah. Okay. So come to the last part of this this session. I think it's most important issue there is the hardware capability is not enough to detect the ISA feature now. Oh, yeah. The hardware cap is using the similar scheme with an ISA region layout. It takes the lower 26 bit, 1 bit per extension for example. First bit for A extension, second bit for B extension, blah, 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 and so on. But now, Risc-V has bunch of multi-layer extension now. Yeah, for example, Back family has at least 10 extensions there. A single letter vector and the ZVE profile. ZVE extension means for the vector for the embedded process. And there is 5 variant. And there is ZVL extensions to specify the vector length for the architecture. And the bit manipulation is a little bit better. They only provide 4 extension in this ratified package. Yeah, but of course there is still a lot of candidates there, but there is only 4 here. And the last one is the crypto family. Okay, I never remember how many extensions there, but I remember almost 10 extensions there. So did some simple arithmetic. Okay, it never can be fit in the 32 bits. Yeah, even we extend the hardware capability to, yeah, it's never enough. And the most important issue is we don't have any way to detect the bender extension, since the X bit only indicates there is bender extension or not, but which bender extension is there? Okay, we don't know. So I believe we need to define the hardware cap 2 or some other mechanism to detect the hardware feature in user space. And there is the major goal of this session. And then let's need to coordinate with the kernel guys. Yeah. So in fact, this issue I talked with many other people. So I put some a proposal I heard before, but and to write some discussion to see any better solution here. Or, yeah.
So I think we need to sort out whether we're exposing like ISAs or implementations, because a lot of the time stuff like string copy is implementation defined. And given how big like the space of possible vector implementations are, I'd be super surprised if that does not even end up more the case.
Mm-hmm.
Right. And like how we encode it is one thing, but first we got to figure out what we're encoding, because
yeah. To me, I would like to encode in the full ISA string, since I also want to handle one thing is the bender extension. Yeah.
Yeah, I guess my problem here is that like there's no way in the Risc-V ISA string to encode like microarchitecture, right? It just encodes the interface, right? So if you need to know like which flavor of vector loads you should be using because you have different performance pathologies in these different implementations, right? That's a very different problem to solve. But I do think it is what we will ultimately need to solve.
Actually, are microarchitectures encoded in the hardware cap strings right now for other architectures?
Well, for AX64 it partially is, because the implementer and part number encoded.
Yeah, that's the problem, is that like all the other encodings of this stuff end up with like a list of implementations owned by a central committee, which does not work for Risc-V.
So I worked recently on the glibc code for ARC64, and one of the uglier parts of it for iFunc is that they're actually testing for the implementer and part number in order to decide what to enable and what not to enable, in addition to everything else. So for the regular questions that we might have, like, do we have bitmanic? Do we have vector? What is our vector length? We should ideally go through something that is independent of the vendor ID. The vendor ID or the part number and the implement ID are still going to be exposed even on Risc-V, as we have the JDEC ID of the implement and the part number.
Yeah, I guess
so
like
there should be a two-level process.
Yeah, it certainly makes sense to say there's a way to discuss the ISA, like definitely without resorting to some sort of table of vendors or whatever, because that's going to be craziness, right? And we'll be able to solve the simple stuff by just looking at the ISA string, right? Because some stuff will just, you'll pick the best one you have. I guess my worry is if we pick something that only exposes that, we are kind of painting ourselves into a corner.
Well, for the problems that we're seeing on the toolchain side today, it's going to help. I mean, string compare, the question there of string length is the are specific instructions from ZBB there? So that already helps. Can we use crypto acceleration as OpenSSL would ask itself? That's also the presence of specific extensions.
Yeah, I guess my worry centers around the vector stuff, where there's a much larger space of available implementations, right? I mean, maybe it's sane to assume for the bitmanif stuff that like if it's there, it's pretty fast. Hardware vendors always violate those assumptions, but whatever, then you get slow stuff, and it's probably not slower than the fallback, right?
That's usually managed by overriding what you expose in terms of hardware caps in inject.
I'm not convinced that like specifically faking hardware caps in order to get a different glibc string compare is like the way to go there. That seems like a big mess.
I mean, and honestly, if somebody really implements it slower, and yes, I've supported a chip for a long time where the vector unit was processing 64 bits at the time, but there were two perfectly fine 64-bit integer units. So if somebody does something, let's put it crazy, then they should go back and patch up glibc in order to actually match their implement ID to override the decision.
Yeah,
so,
I guess so. I guess I'm less worried about this for bitmanif stuff, right, and more for the vector stuff, where like how you load and how you predict and whatnot is going to be quite different between different implementations, and that will not necessarily be exposed at the ISA level, but it will likely affect which string copy routine to use.
You're actually touching at the root of the problem, because it's not just iFunc. If you have that need, you're likely going to have libraries compiled for different vector lengths, and you need to put them into different library paths and match. So this becomes a problem for the runtime linker as well.
Yeah, so like I agree that there is more than iFunc to solve, but I think the same, hardware, I don't know, showing user space what the hardware is mechanism, it should be the same for all of those, or could be the same for all of those, right? Does that make sense? Like, and that's what I'm worried about. Like, iFunc definitely is just one of these users. There will be other users of this. Right?
I mean, the reason why I said that with the library paths, if you're doing iFunc, you usually want to be quick in looking up and matching. But if you're loading a dynamically linked object and want to choose the right one, you can do more processing, given that you have to go out to the file system and do some path traversal anyway.
That's fair. I think there are, though, a lot of libraries that will not actually whack themselves into a different library path, but will detect at startup which flavor of the library to use, right? And then deal with it from there, right? Like that is a fairly common modality that is not iFunc based, because they want to just, basically kind of like a, hacked up fat binary or whatever, right?
Yeah.
And that, again, maybe we can say, hey, iFuncs get the faster mechanism where we have some, HW cap table that encodes the stuff that's really important that we want to pass through, and then the rest of them can just go live with it and parse an ISA string or something. So maybe you're right in that there are different implementations.
Ideally, if we get iFunc designed right, they can just provide different iFuncs that set up the library correctly during startup, instead of going out and parsing themselves.
Yeah, fair. Yeah.
Yeah.
Anyway, I guess my point is that there's definitely more than one use case for this outside of iFuncs, right? But I do think that iFuncs trigger all of the cases that we need, if that makes sense.
Yeah, I think so.
Like I think that it would be a short-term mistake to design around only exposing the ISA bits and not exposing implementation.
Yeah. So I think for those info, we can split it into two parts. First one is just the ISA string stuffs. For example, the iFunc in iFunc's use case, we only care about which extension is there. But Palmer just said in some scenarios, what if we not only just care about the
I would also argue that right now we only care about what ISA is there, because we only have one vendor. So we're not differentiating between the different styles, because there is one style because there is one vendor. Right? That will hopefully change very quickly.
Yeah. So
actually, it already changed, because we can't really use the couple of bits we have with BE and also with the crypto extensions. So this becomes a variable length feature vector, just like with the vector extensions and the vector length. So one part of the problem is we can't really encode it the way we did, because there is no B extension. There is a CBA, a CBB, a CBC, and a CBS.
Yeah, so definitely all of those tables with the letters and the extensions are broken and have been so for a while, and this is kind of just the first time it's concrete, right?
Yeah.
So that needs to get dealt with.
Yeah. Anyway, I just go through some proposal I heard before, but again, I not as I don't have strong opinion here, since I believe it's more like the kernel stuffs. So I just go through which proposal I heard before. First, I think the first proposal is very bad. It's just extend using Hello Cap 2 as extend Hello Cap 1. It's not working is because we just gained extra 32 bits. Yeah, it's never announced. Just in the next page we have bunch of extension. Or we can treat it as a pointer so that we can.
Kito, you only have 3 minutes, so maybe let's just skip the encodings, because we can talk about this on the mailing list. This is like, we're not going to make a decision on encodings here.
Okay.
The other thing I'm worried about that I think does warrant a few seconds of time is, like, how do we turn on ISAs, and like what is the ABI there going to look like? Like specifically, are we worried about like the min vector length, and are we worried about the max vector length in terms of compatibility?
By the way, we have extension to represent the minimal vector length now. Yeah, so it's getting better than we have before. We don't have that. Yeah. So
are we also worried about I'm as worried about the maximum vector length as I am about the minimum vector length, because the maximum vector length is going to trigger a bunch of overflows and stuff, and we'll probably break code later.
Yeah, but if you talk about the vector length, I think the maximum vector length is already defined, well defined in the spec, which is about is the 64K kilobytes. Yeah.
Yeah, I guess my assumption, and maybe I'm just wrong here, is that most implementations will be smaller than that, at least to start.
Yeah,
that's
yeah,
a lot of state.
sure.
And
Sure.
that software will get written that blows up when exposed with a larger vector length. I mean, this is like a super common scenario, right?
Okay.
So I think the decision point is there, do we tell people that that's just a bug and they just get to crash, right? Or are we going to add some mechanisms for compatibility into the probing stuff that says like, okay, well, we know this thing works and only expects 32K of vector state and we'll blow up over that.
Yeah, okay.
Anyway.
Yeah, so yeah, also I just skip this page. I think we are not rushed to make some decision here, but I just throw some my thought. And here is also some thought provided by Philip before, since we mean also using the AT platform or AT based platform, or maybe we can just define our own AUX vector value there. And the AT platform is already used in some targeted before, but for Risc-V it's just set to null point for now. So maybe we can recycle those values to doing something that, but I guess we may need to reserve one of this value for the platform specs, I guess. Yeah. So yeah, I just this
okay, sorry, Keto.
Yeah. Yeah.
Yeah.
So
let's talk more. There's certainly a lot to sort out here. So let's try to talk some on the mailing lists.
Yeah, sure.
Yeah.
And
sorry.
just go through. There's a few pages, some special things to fundraising from Google for adding the iFunction relocation and green time for the kernel path and the Vincent Chen for the vector in iFunction implementation, and then Nelson Shore for this some of proof of concept here. And in fact, there is also a few other puzzles. But I think it's not major broad.
Okay, we got to move on to the next guy. Sorry, Keto.
Yeah. Okay. Thanks,
Right.
everyone.
Yeah. Any further questions? You can continue in the chat room.
Yeah.
Thanks, Kito.
Yeah. Thank you.
I'm trying to find Philip to make him presenter.
Well, in my
You
list,
should have-
I'm on the top.
Yeah,
I
you
got
should.
the plus.
Yep.
So I would
go
have
ahead,
given
Philip.
up another 2 or 3 minutes just to discuss that AT platform issue, because that would really help us. But let's jump in, change the pace a bit, and talk about something entirely different, which is a toolchains topic and a compiler topic and infrastructure on that front. And also wraps up or touches on many of the other things that we have, like hardware availability and how to get the software ecosystem up. So life is a bit complicated, as we already realized today, because we are actually looking for enough hardware out there, talking about touching desktop and server class systems with the platform with the platform specifications, while most of the data and most of the effort has really gone into small benchmarks and also small systems. So Risc-V has a pretty good stronghold in deeply embedded now. And in embedded, and that means that we've been evaluating our development tools and how to get performance out of this with tools like Drystone, EMBC. I know a few people have been running spec, not just us. But it has been significantly less effort put into it. And it's not surprising that these small benchmarks are favored by a lot of people because they're well understood. They require little resources and they're easy to work with. Expand our coverage towards larger benchmarks, prioritize improvements where it matters most. And we've done some work on that I want to touch on, and also see how we can get more of the community into this and additional groups to help us out on that. So I know this is more of a kernel-oriented group, so I'll just very quickly circle back and summarize what the spec benchmark suite does and what spec CPU 2017 does. So this is a large standardized benchmark suite. It covers both integer floating point, has plenty of vectorizable workloads in it, and covers both single core and whole systems. So you run multiple copies, you run threaded instances of the benchmark and look at how the system performs and scales up. It has built-in validation, which comes in really handy to figure out subtle bugs in compilers or even in emulators. So just recently, we found a quite subtle bug in QEMU's bin manip implementation based on running all of spec. And it comes with well-defined run rules. Generally, where it's coming from is comparing enterprise class systems, comparing workstations and servers. And it's trying to mirror real-world workloads and allows real-world benchmarking of Linux servers. So XML processing is one of the workloads, X264 is another one, and even a slimmed-down version of GCC is a pointer chasing benchmark that's in the suite. So there's only two drawbacks with that. The first one is it comes with a license agreement, and that license agreement is not excessively friendly of collaborating based on it. So everybody needs to have their own license, and then you can share data and observations, but you're not allowed to share the benchmarking suite itself. The other drawback is that it requires large memory and has considerable runtime. So while we can't really do much about the license agreement, what we're talking about here today is, and what we've done over the last couple of weeks and months, is we've done something about the considerable runtime and the memory by simply running it on, instead of on the target systems on QEMU, and doing a lot of analytics on it in order to qualify and quantify how well our compilers work today. So some of you might wonder why anybody is caring about that on Risc-V today, and the problem is the competitive landscape. So everybody else is optimizing for spec, and this is driving investment decisions, this is driving uptake of systems, or sometimes it's just generating good versus bad media feedback that will reflect on how well the device is perceived in the market. And everybody else, and literally everybody else, so Intel, AMD have been focusing on that. So ARM has had an effort going for about 3 years to improve their performance. There's a talk that I linked from Kernel at the 2019 GCC Cauldron. ARM announced auto-vectorization improvements for their architectures based on that. And finally, Intel's ICC and AMD's optimizing compilers have considerable optimizations for that, including structure optimization. So for us, life is even harder than for ARM. So ARM had vectors, but they were just missing certain instruction patterns and could get the speed up. So for us to catch up with them, we will have to work on multiple fronts in parallel. So that means vectors, that means the bit manip instructions, and so forth. And generally, to do that, it would be useful having some tools that guide us and having tools that help us along. And right now, all of these new instructions don't really have hardware that we can test it on. So the methodology that we're using and the setup that we've put together at the moment is we're using QEMU to emulate the target hardware. That's quite straightforward. But on top of that, we've written a plugin to capture the dynamic execution profile. So it's doing similar things to what Perf does. However, it's doing that on a trace block level. So every basic block, in order to capture the frequency of those, and also how many dynamic instructions relative to the entire benchmark are spent on each of them. After that, we do some out-of-band analysis on the captured data for two reasons. So one of them is we're interested in histograms to understand how the instruction breakdown looks. And the other one is that we need to really understand what are the hottest blocks, why do they look the way they do. So the histogram data is quite useful in understanding if we are having good coverage of our instruction set, if there's instructions we wouldn't expect popping up frequently, usually extension operations, and generally getting a high level view if what we're doing is right. So for example, if there's no minimum and maximums popping up, we have to dig in deeper and figure out whether if conversion is working. And those are qualitative measures that we can apply very, very quickly. And on top of that, we're feeding current GCC and current LVM into the analysis. So compiling our standard benchmark workloads at the moment, that's CoreMark and Spec with different settings, and then running that against the setup in order to collect the data. One of the drawbacks of all of this is that the analysis as of today is mostly happening by hand. So yes, we can do certain comparison, like seeing whether other blocks have gotten hot, so whether there's a significant change in the hot blocks, or whether instructions are hit that we'd expect. But to really understand whether each of those blocks, and I'll show some of them, is a reason for concern, we have to go in and do that by hand. So as I said before, we're doing that with QEMU. We're duplicating some of the things that Perf can do. And the question, this begs the question, why not using Perf? So at this point, we're just lacking the right hardware. So some of this work, or a lot of this work, is trying to predict where we are with in terms of our compilers if certain non-ratified extensions were already implemented. So the software tools and the hardware needs to co-develop. And then there's another thing, actually QEMU has unbeatable performance and access to large memory if we run it on a large Intel server. Probably not the thing one should say in the Risc-V community, but everybody knows we are waiting for the high performance silicon at this point. And finally, what we are hoping is that doing this approach and just counting dynamic instructions will be unbiased to any specific microarchitecture and should, for that reason, allow us to share data between the competitors that are collaborating in the Risc-V field. So we're all trying to advance Risc-V, but in the end, everybody who is developing a microarchitecture is a competitor. The assumption behind all of that is if we reduce the dynamic instruction count, we hopefully should also make things run faster. Yes, there's always corner cases in microarchitectures, but that will have to be dealt by individual vendors. Now, I'll show some example use cases just to illustrate how this has been coming in handy over the last months and what sort of questions we started to look in using this methodology. So instruction histograms to just look at how valuable is bitmanip or the various sub-extensions of it. what's going to be the expected benefit of CBO 0, and can we confirm that it works? So how do we identify targets for it? And then I have 1 or 2 examples of code generation quality in the backend that we're currently working on that have fallen out of this. So maybe the first and easiest question, since I was talking about the histogram generation, is how CBA-BCS are we? I mean, the slide was originally titled "How Bitmanic are we?" But given that we've broken it up into 4 sub-extensions, it doesn't sound as sexy anymore. Using this approach and using this methodology allows us to really run each one of these major benchmark workloads. So there's Perl in there, there's GCC, there's Blender, B-Waves, X264, and Xalen against various compiler options, do that automatically, collect that, and look at how likely are these things going to help. And this information tells us 2 things. Number 1, we see that these instructions do generate significant value. So if I get 10% of all instructions being addressing instructions in a benchmark, and these addressing instructions generally replacing 2 or 3 individual instructions, this is going to reduce our dynamic instruction count significantly and also accelerate things. At the same time, it tells hardware vendors how they could optimize or how much they could win if they support these extensions. So that is data that is equally valuable for us on the toolchain side and on the hardware development side. Another question, and that is actually quite old data because the postfix 0 extension was removed, was how does the instruction count really change if we have prefix 0 extension and postfix 0 extension? And should this be really included, so quantitative data for ISA development? And it turns out that there wasn't really a movement. So you have prefix only, you have postfix as well, nothing really changes. And that indicates that we'd just be wasting opcode encoding space and generate complexity for the compilers if we'd include a feature like that. But now after histogram data and just looking at the large-scale quantitative effects, a lot of people are probably wondering CBO.0, how useful is it? I mean, in the kernel space, it makes perfect sense. We need to zeroize pages before we allocate them and hand them out to the user space. However, there's one interesting benchmark that pops out, which is GCC. And surprisingly, we see about 2.7. So I've only included the 2 of the elements. So there's more recurrences because otherwise the number would be wrong. 2.7% of dynamic instructions spent in an unrolled loop that stores 64 bytes. So if one looks into the code, if one looks into the call chains, this is always called as a memset with setting it to 0. If we replace the sequence of SDs with a single CBO.0, so 64-bit cache block size, cache block operation that would write 0, this would be reduced by 1.855% of total dynamic instructions, probably making the benchmark approximately that much faster. If somebody has a microarchitecture that can't process so many stores but has a fast CBO.0, they might see an outsized benefit. If they can get rid of the stores very quickly, it might be a bit less. But generally speaking, CBO.0 is shown with that to have a real-world application and make things faster, even if it's just in the 1-point-something% range, just based on that quick analysis. Another example would be spotting trouble in the backend. So that one was actually quite surprising. just reviewing. So this is coming from XC, from the compression decompression benchmark, and looking at it, there's a sequence that just smells odd. So a lot of zero extensions, which are those add.w's, following each other, and not much happening. So when looking at that more closely, it becomes apparent that this has to do with how the minimum is computed, and that there's just a bit of backend work necessary in order to make sure that we can eliminate some of them. And when looking even more closely, there's also opportunities to use bit manip instructions or different bit manip instructions in case of the shared the shifted by 2 add and the adds. In the end, this turned out to be a 35% reduction for this specific block, which would reduce the dynamic instruction count by 1.8. Again, your actual speed up is going to vary with microarchitecture. But if you make a basic block that has significant runtime on the benchmark or significant dynamic instruction count shorter by a third, you're going to have some remaining benefit. And finally, the most surprising one from my collection of issues that I went through in our tracker was a zero extension that was nonsensical and could have been eliminated, but was stubbornly refusing to disappear. And when looking at the intermediate output, the debug output, it turned out the compiler actually saw the opportunity to eliminate it in its redundant extension elimination pass. However, it decided not to, and that deciding not to can be directly traced back to a fix me in the GCC code that will need to be addressed in order to get the best benefit out of it for Risc-V. So in general, we're proposing to have a method that goes from QEMU through plugins into an analysis and sharing that data across the entire Risc-V community in order to identify and drive our compiler development. So we have a backlog of things we're working on. So one of them is to contribute the tools, which are the QEMU plugins, back to the community. So one of the things that has come out of the work is that we've already submitted updated patches for the CPA, B, C, and S extensions upstream into QEMU. We have some code generation issues to address at the moment. Our own tools and our plugins should eventually become multi-thread safe, which they aren't today, unfortunately. And then there's plenty of work to be done on the analysis tool. So on the automation side, on being able to automatically spot common problems by reconstructing a graph out of a basic block, and then identifying nonsensical extensions, for example. And finally, adding more benchmarks to improve coverage. Plus finally also to do this in more configurations, because right now the focus is on RV64GC plus the B extensions, and in the future hopefully some additional work with vectors, but the compilers actually need to firm up on that front, because a benchmark suite like spec is not going to get a lot of a benefit without the auto vectorization being in place. So at this point, I'd like to open the discussion and really say, what thoughts does the community have? How can we move that forward? Where is it useful? By asking if anybody else is working on spec CPU 2017 performance, and seeing if there's ideas on how to integrate that with performance simulators, where and how we could get the infrastructure publicly shared to have the data that we generate available to all of the members. And what other benchmarks people would be suggesting and would like to see. And all of that with the goal of avoiding duplication of effort and also getting things to firm up quickly and get them into a state where we can submit them to the various projects. So this may be glibc at times, this may be GCC or LVM, without wasting the maintainer's time, and to get this committed upstream. So again, we're having to play catch up with Intel and ARM, and the intent here is to create a tool or to share the tools that we have developed in order to drive our catch-up game. So with that, comments, input, ideas. So Aaron, I've just seen your message in the chat. Send an email to me.
Is it already available in any of the mailing list?
First parts are in the mailing list, but we are getting ready to actually push the plugins out. As I said, they need some cleanup. The first stage is going to be to push the hot block generation upstream into QEMU as a new plugin. So those patches are being readied at the moment.
Philip, so any of this SBI PMU and the counter overflow and all those things will help if those things are there in upstream then?
Actually, we're doing this in user space, so we're not doing full system simulation. Okay. But once these things are upstream, I would be looking forward to having the perf results and correlating them.
Yeah, that's what I was about to ask. Instead of QEMU plugins, if perf, as of now, at least if you take my patches in all the projects, it should work.
Okay. Philip, one question. Do you really require perf record immediately, or you need it's mandatory for you, or you can just live with normal perf?
Well, for correlating, we could live with normal perf, but again, we've built this as a separate infrastructure. So we can even collect the data based on a whole system image, although we lose the some of the disassembly information.
So when you say whole system image, do you mean everything that's collects statistics while the entire system is running, or you're talking about different privilege modes? Because you can filter them out with perf as well.
Basically QEMU system. So if you run this against QEMU system, the most useful piece of information is disassembly snippets and
okay, got it.
We're really focusing on user space processes at the moment.
Okay. So
that's how we measure compiler quality.
So in case you need perf, do you need perf record? Because that's also supported now. I mean, the patches are there.
For QEMU, yeah.
Yeah, for QEMU, of course.
Okay. So it would make sense to actually correlate the information then.
Sure.
Okay, so I mean, Philip, so what is the larger vision here, like to create a database of like what workloads or what?
Basically similar to traces. So what we want is a database of the dynamic behavior of individual benchmarks. So we get hot blocks information, we see what they do, we know where to look on each benchmark. So that's why I said if we have additional benchmarks, we can generate more valuable data. The other thing is eventually we'd like to be at the point where we can run this nightly. Against upstream toolchains to just rebuild and run the compiler and this against multiple workloads and compare whether we get regressions or improvements. I know this is not infinitely useful, but it's going to be another quality assurance tool. And the other thing is LLVM and GCC have quite different performance characteristics still, or at this point. And this can also guide us in allocating resources to the various parts of the compiler, seeing what works in the one project and could be ported or duplicated in the other one. So really, this is a tool that or the vision is to create insight into where to allocate the resources and where the trouble spots are, and predict what gives us the biggest improvement for the resources allocated, given that the Risc-V community has a lot to do and definitely not infinite resources.
Do you think this moving in a direction where it's also a sim point database or something workloads for sim?
In a way, yes. So Valgrind, for example, hasn't been ported to Risc-V yet, or not fully ported. And we recently looked at creating basic block vectors, which is sim pointing data, out of QEMU, and we just modified these plugins that we had. So that was actually quite an easy changeover. To move from what we were doing there to generating basic block vectors for sim pointing. So I'd say the application and the use cases are similar. Our focus is really on analyzing the benchmarks and seeing what the trouble spots are. So where the time is spent and why the time is spent there. And then comparing the tool chains. Not necessarily for creating sim pointing data sets for predicting hardware performance.
Or maybe at least you can provide a simple framework. If someone wants to take this and start creating sim points, then
again, we've basically run this with slightly modified code, and changing this over to create a basic block vector file for the sim point toolkit was about a week's worth of effort.
Okay.
So the challenges are very similar, but we're approaching this, or we've been approaching this from the toolchain perspective, and from a quality and quantification perspective, instead of from the hardware perspective.
I think we are over time as well. So are there any other questions? Okay, I don't see any other question in chat room as well. So I think we can conclude the session today. So thanks a lot. Thanks everybody for attending it and having great discussion.
I'm supposed to do the sponsor slides before we conclude. Do you want to run through those?
Oh, you want to do the sponsor slide?
That's what the email said.
Oh, okay, sure.
I think.
So,
you can do it.
Is there anything beyond Diamond? No, Diamond starts. So thanks also for our sponsors. Diamond sponsor Facebook, Platinum sponsor IBM, Gold sponsor Almond Microsoft, Silver sponsor AWS, Netflix, and Red Hat, Speaker Grid sponsor Collabra, and T-shirt sponsor VMware. And thanks for Linux Foundation and the planning committee for having this platform. Like, at least to me, this is the best virtual conference that I have attended in last 2 years. So thanks a lot for that. We do have, as we discussed earlier, we do have a Bob session coming up on Friday. It's in the calendar. It's in the chat also. The details are shared in the chat and in the shared notes. So we'll be discussing, we'll continue discussion on the platform.
There's also a Bob at the GNU Tools Conf.
Yeah. So what's that about? Is it overflow
Yeah, it's very much a BOF with no scheduled stuff. So obviously a little more toolchain focused because it's inside the tools microconference.
Okay.
But yeah.
Okay. Awesome. Yeah, so please attend that if you want to have more discussion on our platform. Attend the toolchain one if you want to continue the discussion on iFunk and iFunk details, what Kito was presenting, and for the platforms and D1 discussions, please attend the Risc-V platform specification BOF on Friday. I think any last minute thoughts, Palmer?
Nope, nothing for me. Thanks, everyone. This was a good one. We'll talk more.
We'll always talk more. Okay. Thanks, everybody. Have a good day, good evening, good night.
Thank
So
you
I'm
all.
supposed to click end meeting now, right? Instead of leave meeting.
I have no idea. It probably says somewhere in the documents.
I'll just do leave meeting in case.
Okay, but we might need to click end meeting because I think we're not supposed to leave them running. Let's maybe, why don't you click leave meeting and then I will try to read the document. Try to figure out if it's supposed to click. Unless you want to do it, I'm happy to be done with my responsibilities for now.
Anyways, I think we are done with the meeting, so end meeting makes sense. I'll just do end meeting. Thanks. This action will end the session for 27 active users. Okay, thank you.
All right, thanks guys. Bye.
Bye.
I think.